And this time I find myself around an extremely beautiful, mysterious planet where we seem to have found ourselves extremely lucky to observe a solar eclipse. But anyway, I'm actually going to be away for a few days, nursing my voice, mostly because it's not really doing so well. I mean, I think I caught something, or maybe I'm just talking too much. Either one of those. Either way though, in this compilation, we're going to be exploring a lot of different mysteries, a lot of unexplained mysteries, and a lot of anomalies that nobody understands even today. They're actually going to be coming from various locations, including planet Earth, and only a few of them have a potential resolution. So enjoy, and I'll see you soon. Back in 1988, somewhere in the province of Quebec in Canada, there was an unusual pink-purple globe detected flying above the St. Lawrence River. An object whose nature and whose origins were unknown for many years, technically still unknown today. And although initially it was obviously assumed to be some kind of a UFO or potentially some other mysterious and hard to explain phenomenon, eventually it was followed by something else. It was followed by an earthquake. And this is where our story begins. Hello wonderful person, this is Anton, and today I wanted to talk about this really interesting concept that's technically becoming an actual scientific concept simply because of the amount of evidence that seems to suggest it actually exists. And no, we're not talking about UFOs, mostly because I still think it's nothing to do with science. We're talking about something way more interesting in my opinion. We're talking about earthquake lights. These strange phenomena that seem to appear during very powerful earthquakes and that in theory could actually explain various UFO phenomena as well. And one of the main reasons why it was very difficult to believe the phenomenon existed was actually because of the poor quality of various pictures. For example, here's a picture from Romania from the 70s. This is a courtesy of Seismological Society of America. What exactly is this showing us? It's showing us something, but it's hard to actually distinguish anything here. On the other hand, this picture by Jim Conacher taken in Alaska in the 70s shows us something with slightly more detail, unusual yellow lights above a lake. But in this case, it's still kind of difficult to explain what exactly we're looking at, or even if this is a real phenomenon. But both of these phenomena were followed by a relatively powerful earthquake. But the reports of these lights appearing after earthquakes actually have a very long history of being reported in a lot of different literature. As a matter of fact, the first ever mentioning of an earthquake light was back in 869 in regards to a relatively powerful earthquake in Japan. But more and more reports start to come out in the 20th century and way more in the 21st, especially with the advent of CCTV and various smartphones that do have much more powerful cameras. And in every single case, it would involve some kind of a relatively powerful earthquake, at least 5.5 on the Richter scale. And the interesting thing is that usually these lights were classified as either one of the two. Either unusual globular formations usually flying above the area where the earthquake would occur eventually. This is something that happened back in 1975 in Hawaii. Or the lights generally resembling a typical aurora, but usually white or blue in color, with the lights themselves appearing and disappearing in just a few seconds, occasionally lasting for a minute or so. And so, for example, in 1930s, once again in Japan, there were lights that were visible from a distance of about 110 kilometers. But more recently, the devastating 2008 Sichuan earthquake produced lights that were visible from approximately 400 kilometers away. None of this was recorded on camera, or at least not reported by media, but it was reported by several witnesses. Similar phenomena were seen in 2003 earthquake in Mexico, in 2007 earthquake in Peru, 2009 earthquake in Italy, 2010 earthquake in Chile, and even the powerful eruption of Sakurajima volcano also resulted in the production of these lights. Or at least that's what was claimed by the eyewitness accounts. And up until about 10 years ago, most of the scientific community was still relatively skeptical about the existence of this phenomenon simply because it seemed a little bit unrealistic. How exactly would the light be produced because of the earthquake? Yet more and more reports started to come out, and with the advent of social media and more importantly smartphones, we started to get actual evidence, video evidence. Now at first it was just photos, once again showing us unusual lights. For example, this is from 2009 in Italy, with certain pictures and videos not really showing much, and certain other pictures looking a little bit too unreal, even though these were actual photos. But then we started to get actual footage from actual witnesses using smartphones. And this is absolutely incredible. This shows you what these earthquake lights were like during an earthquake in 2021 in Acapulco, Mexico, with these phenomena being captured from a lot of different angles by a lot of different people, and some of them just being completely unreal. It literally looks like the entire sky is exploding with these lights. Now what exactly is happening here? And more importantly, is this an actual real scientific phenomenon? And of course not everyone believed what they were seeing. Well, some of the explanations for these lights do make sense. These were maybe exploding transformers. As a matter of fact, at least one video from Acapulco that you see right here, and as always you can find in the description below, shows us what happened right there. This transformer exploded, producing the lights above. But this single explosion doesn't actually produce enough light to illuminate the skies just as we see behind it. So something else, more powerful, was causing a lot of these other flashes. For example, in this case right here, the actual light seems to be coming from above the skies, not really from below where the transformers would be located. Similarly, in this video right here, it becomes obvious that some of the lights also seem to be different color, so they do seem to have slightly different origin. And so following this earthquake last year in 2021, that's sort of when a lot of scientists suddenly realized that maybe this is something after all. And specifically because even very recently, both in China and in Japan, we had even more evidence for the existence of these unusual earthquake lights. These lights you're about to see, that's from the very recent earthquake in the same region of Sendai in Japan, with this video being taken on March 16, 2022. And as you can see from the power of this flash, it's unlikely to be a transformer. Something way more powerful would have to produce the light we're observing. But that's where we enter the realm of unknown. At the moment, it's really unclear what produces this. But from all of the available evidence so far, some of the scientists established that it seems to be possibly two different phenomena. One of them, resembling a typical aurora, usually happens either during or slightly after a very powerful earthquake, at least 5 on the Richter scale. But then there is also something that seems to happen before the earthquakes, sometimes even a few weeks before the earthquake occurs. And this is something that's observed very close to the epicenter. And sometimes this resembles a ball of light, sometimes it resembles something slightly different, but it seems to resemble a typical object we would classify as a ball lightning, or sometimes resembles a ball of light that hovers and disappears slightly after. So yeah, it sure sounds like a typical UFO, but a lot of these events seem to be pretty much natural. But aliens, they're not, because there are actual scientific explanations for what could be possibly happening here. It's just not entirely clear which explanation is the best. For example, in one of the explanations, it involves a chemical reaction. In this case, through the breaking of different bonds inside certain minerals, for example dolomite or rhyolite, it's possible to produce very high stress that can then release oxygen that actually becomes ionized. And once these ions escape from the cracks in the rocks, they can then start ionizing the atmosphere, forming plasma that emits light. Actually, the plasma ball you see right here is produced in this way, with certain experiments in the lab suggesting that this could actually explain some of these phenomena. So for example, by having certain locations with relatively vertical folds or cracks, this in theory can produce a lot of ionized oxygen, thus producing a lot of light. But that's of course just one of the explanations. The other explanation involves the principle known as piezoelectricity, the same principle usually used in a typical quartz clock. And here, through the mechanical motion on the quartz crystals and through sheer power of the earthquake, this can actually produce a lot of electricity, which once again could maybe produce some sort of ionization in the air. Another explanation involves the magnetic field of our planet, and specifically the interaction between these very highly electrically charged rocks and the magnetic field above the region, with these regions then triggering some kind of an aurora-like event. And the last explanation involves a phenomenon that we know exists but also do not understand. This is known as the triboluminescence. It's the unusual production of light when certain minerals, in this case once again crystal, are mechanically pulled apart, ripped, scratched, crushed or rubbed, and end up producing the light that you see right here. And so trying to use this phenomenon that we barely understand to explain another phenomenon that we really don't understand is not really good science. But nevertheless, it is one of the possible explanations for how some of these lights that have been observed in various regions on the planet seem to be produced. But even though we don't understand what's happening here very well, we do understand where these events seem to occur. The vast majority, or about 97% of all of these lights, for the most part have been associated with these so-called subvertical faults. The regions which only cause about 5% of all of the earthquakes on the planet, and essentially represent a region where the tectonic plates are stretched and pulled apart, causing various vertical cracks. In contrast, the majority of earthquakes on the planet are usually caused by the subduction zones, where one plate is slipping below the other. And so knowing where these earthquake lights happen could one day help us figure out what's happening here. But more importantly, or more practically, it's already been suggested that detecting these lights can actually help us predict future powerful earthquakes. With several studies from Italy, for example, already suggesting that it has been done in the past where people detecting lights and knowing about this phenomenon has actually provided shelter for several other people in their basement, which saved their life. In other words, by being able to somehow detect these lights across the planet, possibly using some kind of a satellite system, at least in theory, we could maybe predict earthquakes, powerful ones, or at least in certain regions of the planet where these lights do appear. Which of course makes this a pretty interesting topic that we're going to be exploring again once more studies come out. Hello wonderful person, this is Anton, and today we're going to be discussing a somewhat intriguing paper that suggests strange stars actually exist. And here it's actually kind of difficult for me to even help you visualize this. We're not really talking about stars that are just weird or strange. We're talking about stars or objects made out of what's known as strange matter, which by itself is made out of what's known as strange quarks, essentially matter that does not exist here on planet Earth, or I guess technically could exist for like a microsecond in some kind of a particle accelerator, but theoretically has always been suggested to be a possible type of matter that could exist inside, for example, neutron stars, or might have actually existed in the beginning of the universe, with hypothetical objects known as strange stars still in existence today. But in this case, we're going to be discussing this particular study that's actually a follow-up or an additional observation from another previous study, the one you can find in the description below, that seems to have confirmed these initial observations. Basically confirming that the observations from the supernova remnant located somewhere right here seem to indicate that there is an unusual object in the center whose current physical properties are extremely difficult to explain using modern physics, implying that this unusual object has a very high chance right now to actually be the first ever confirmation for an existence of very exotic objects. In this case, the objects were referred to as strange stars. But I guess let's start with baby steps. So here's how all of this kind of started. It basically all began with the discovery of a new supernova remnant. And as you might already know, most supernovae usually result in one of two things. Either some kind of a black hole remnant, what we usually refer to as a stellar mass black hole, or potentially a neutron star. And it's really the mass of that initial star that went supernova that determines what's going to be produced. More massive stars result in black holes, less massive stars result in neutron stars. Although actually extremely massive stars can sometimes leave nothing behind. But that's something that only happens to some of the most massive stars we've discovered so far, and as a matter of fact has never really been seen physically either. Nevertheless, remnants, including neutron stars and black holes from various supernovae, have been seen many times. But when looking at this particular supernova remnant that was discovered a few years back, the scientists using various telescopes and using multi-frequency observation discovered something unusual on the inside. Okay, it wasn't really unusual at first. It became unusual with further analysis. It seemed to be the lightest neutron star ever discovered, or the least massive neutron star ever discovered. But in this case, way below even theoretical mass. And this would have been totally fine and not really a problem if this was a white dwarf, because white dwarfs typically have this mass of about 0.8 solar masses, but this would create a new problem. A supernova cannot possibly produce a white dwarf unless it's a type 1 supernova, where a white dwarf explodes but does not explode completely. But this was not the case. All of these emissions indicated a type 2 supernova, and the emissions from within, specifically the X-rays, indicated that this was not a white dwarf, but very likely a neutron star after all. But the thing is, this wasn't really a problem until recent observations from the Gaia telescope. Because at first the scientists believed that this was a regular neutron star, but turns out that their distance calculations were incorrect. When Gaia telescope recalculated the exact distance to this object using some of the most advanced astrometry technique that we currently have, the distance was determined to be approximately 8,150 light-years away from us, not 10,000 light-years as previously assumed, which implied that the central object was not as massive as initially thought, and really implied that this was the lightest neutron star ever found. Previous measurements of its mass were actually much higher. But the thing is, the current models for the star collapse do not allow for such low-mass neutron star. With so little mass, it really can only be some kind of a white dwarf, at least according to previous theories. As a matter of fact, the lightest neutron star that's accepted by everyone to date is a neutron star located in the pulsar binary. In this case, the lightest object is about 1.17 solar masses, and even here that lower mass is a bit of a problem. But at 77% of the solar mass, it really makes no sense whatsoever. So what exactly is this object then? And at the moment there seems to be only one potential explanation that kind of makes sense. It's really in regards to how matter changes when it finds itself in extreme conditions of high pressure and very high temperature. Now we're all familiar with ordinary matter, the stuff that we have on Earth. That's the stuff made out of atoms, sometimes also referred to as atomic matter. But as you go deeper you find nuclear matter. It's sort of like a liquid composed of neutrons and protons that by themselves are made out of even smaller stuff, the stuff we refer to as quarks. And everything around us that we're familiar with is made out of up quark and down quark. But there are obviously other quarks. Specifically, there are strange quark and charm quark, sometimes also referred to as the second generation quarks. And the combination of strange quarks with, for example, up and down quarks starts to produce other subatomic particles which have been used to explain a lot of other phenomena in various particle physics, with a lot of these calculations and explanations generally being in the domain of condensed matter physics or quantum chromodynamics. And so some of the theories in this field propose the existence of what's known as strange matter, basically matter that's composed of strange quarks, remaining in a stable state and not dissolving into anything else, unlike in regular conditions on planet Earth. And in this case, a lot of these theories have actually proposed that this type of matter can definitely exist inside neutron stars in extremely dense, very hot conditions, where basically matter dissociates into quarks, creates what's known as quark matter, and some of this quark matter then starts to convert into specifically strange quark matter, eventually creating this relatively permanent matter that doesn't actually dissociate into anything else. Another way of seeing this is by imagining a neutron star as a kind of an ocean of neutrons, with all of the quarks in this neutron star confined into individual neutrons. But at some point, in just the right conditions, this confinement disappears and creates free-floating quarks. This is what we refer to as a quark star. But as a lot of these up and down quarks start to convert into strange quarks, potentially creating a more stable structure, they then turn into this hypothetical strange star. And what's really intriguing about this proposition is that it suggests that this particular object might actually be a permanent structure. This refers to an idea known as strange matter hypothesis. And in this case, the hypothesis suggests that pretty much everything around us, all other matter, is not permanent. It decays over time and becomes something else. Or basically, a lot of matter is metastable. Given enough time, even nuclei and protons and neutrons around us are going to turn into something else, eventually maybe even becoming just energy itself. But not strange matter. Droplets of strange matter seem to be permanent and do not disappear. These droplets are sometimes referred to as strangelets. And in the last few years, the scientists identified at least 8 potential candidates to be these unusual strange quark stars. And the most exciting candidate we've discussed just over a year ago, with the video in the description. But the recent additional observations of this unusual object once again confirm that something here does not add up. It does not seem to be a regular neutron star, and so by double-checking the mass, the radius, and the surface temperature, and comparing this with equations that involve some kind of a strange matter, these models seem to actually align with the observations. Hess J1731-347 might be a strange star after all. Although in this case, it would still have some neutron matter on the surface, so it still possesses certain properties from a neutron star and still creates certain effects. But if this is the case, it's still not clear how exactly this object was produced. There is really no theory or no explanation for how a supernova can result in the production of this unusual object, and what processes led to the production of a strange star and not just a neutron star. One proposition is that for some reason there might have been even more energy in the collapse that resulted in the removal of the mass, leaving a huge amount of quarks behind. But some other models even propose that maybe this is actually something that all neutron stars possess, but in this case the neutron star might have just lost its outer shell, leaving behind nothing but the Quark star or the Strange star. Whatever it is, still really exciting and will probably result in even more observations in the future. Although in this case, if this is actually a Strange star, and if it's real, it potentially solves another really important mystery somewhere out there in the universe. The mystery of fast radio bursts. Powerful radio signals detected from everywhere in the universe, pretty much several times per day, whose existence have been previously explained as a potential collapse of the crust on top of the Strange stars. So if that tiny crust of neutron matter collapses on the surface of a Strange star, it can actually result in what the scientists describe as a fast radio burst. And because we've been seeing so many around us, and because many of them still do not have a very good explanation that explains all of them all at once, some theories propose that maybe this is a Strange star phenomenon after all. But unfortunately, until future observations and future discoveries, and especially analysis from other candidates that have been discovered before, we're not really going to know much more. Hello wonderful person, this is Anton, and in the past we've discussed a lot of different events that happened to our planet that to some extent influenced life on the planet for one reason or another. In most of those cases though, those events happened millions and millions of years ago. For example, various supernova that we know influenced the planet in the past. There are quite a few videos about this in the description. But there are other events that we've detected that only happened in the last few thousands of years that seem to have incredible effects on the planet as well. And we only started to discover them in the last few decades. And these events and their effects were only discovered in the last few years. The most famous such event was found approximately 10 years ago in 2012 and officially is known as the 774-775 carbon-14 spike. And that's because either in 774 or 775 something happened to our planet and it resulted in a dramatic increase of the formation of carbon-14 discovered as a kind of a layer in various tree rings in a lot of different trees around the planet, especially trees that were at least a few thousand years old. And generally this means that something dramatic did happen in the upper atmosphere, very likely resulting in a lot of radiation reaching the surface. And that's of course based on what we know about carbon-14 and how it's generated, with the generation process being important to understand in order to see where we're going with this story. Now obviously a lot of life on the planet uses carbon dioxide, but the carbon molecule in here can actually be a little bit different. It can be typical carbon-12, which is of course the stable version of this particular atom, but in other cases it can also be the radioisotope known as carbon-14. Carbon-14 is a lot more rare and is actually produced when various types of cosmic rays and relatively powerful radiation strikes the nitrogen atom in the upper atmosphere, resulting in the production of this relatively short-lived isotope. Its half-life is approximately 5,730 years. And generally the background cosmic radiation striking the planet is more or less the same every day, although it does vary depending on the solar activity, which of course means that carbon-14 is generated in the upper atmosphere at a relatively same rate. But once in a while, when there is something really active happening in the upper atmosphere, such as for example some kind of a powerful solar flare, or in some more extreme cases, some kind of a supernova releasing huge amounts of energy that then strikes the upper atmosphere, something that's more theoretical, but something that we believe does happen once in a while. In this case, the production of carbon-14 increases dramatically, and thus more of it starts to be deposited in various trees on the planet, appearing as a very specific spike in certain tree rings. And this is essentially how the scientists in the last few years were able to analyze and discover a lot of different very powerful events that happen on the planet in the last 10,000 years or so, by basically looking at various tree rings from various ancient trees. And in 2012 they found the biggest one, or at least one of the biggest ones. The spike here involved an increase of carbon-14 by approximately 1.2%, which would suggest the radiation levels at least 20 times higher than normal background radiation. Now obviously this would not result in an extinction event, and most of the life on the planet would probably not even notice it, but it's still very important for our modern way of life. This type of an event would result in a dramatic increase of radiation in outer space, affecting the astronauts, affecting the spacecrafts and a lot of different satellites, and just generally affecting our way of life as well. The satellites might not even survive such an event. And because this event was originally discovered in the Japanese trees and by Japanese researchers, today it's unofficially referred to as the Miyake event. As you might have discovered in one of the previous videos from a few months ago, turns out that these events are actually not really rare. More events have been discovered in the last 10,000 years, with some potentially even more powerful than this one. And so in the last few years, especially since we've discovered all of this, a lot of scientists wanted to learn more about it, specifically trying to figure out how exactly this would affect the planet if it happened today, what exactly happened here, how frequent are these events, and most importantly, was this basically coming from our sun and was a result of some kind of a super flare suggesting that our sun is just a little bit more mysterious? This, by the way, was the original proposition and the original explanation here. Or is it not really from our sun and from somewhere entirely different? Potentially another mysterious event we do not understand. Short spoiler, it's not our sun, it seems. So first of all, in the last few years, a lot of different researchers from different continents discovered very similar signs of these events in a lot of different countries. Germany, United States, New Zealand, suggesting of course that this was a global event that lasted for at least a year, possibly even longer. And it involved a very sharp increase in radiation, possibly from some kind of a bright flash or something else that happened very suddenly, followed by a relatively gradual decrease over the period of several years. It's a little bit easier to see it in this graph where you can kind of see that within about 5 years it returned back to normal. But the spike itself is very obvious and very pronounced. In this case, this was actually a confirmation study based on the increase of production of beryllium on top of carbon-14. Once again suggesting that this was something related to radiation. But it doesn't seem like it was a very long event. It obviously disappeared pretty quickly, but affected the atmosphere of the planet quite dramatically, more so than any other event in the last few thousands of years. Naturally, one of the first things the scientists wanted to do is to actually see if there's any historical record of any of this, possibly written down by the ancient empires, for example by the British or maybe by the Chinese. And it just so happens that in the Anglo-Saxon Chronicle, there is a mentioning of something like a red crucifix appearing in the heavens after sunset. But what exactly was being described? Well, it could be the aurora, which would also imply that something extremely powerful happened on the surface of the sun. But the question is, of course, could it have been something else? Could it have been, for example, a supernova? Could it have been something entirely different, possibly detected by someone else? Well, back then, the Chinese astronomers were much better at writing things down. But the ancient records from the mid-770s don't really tell us much. They do talk about one aurora that happened in 776, and they also mention some kind of an anomalous thunderstorm in 775. But no mention of unusual star or unusual observations in the night skies. So a large visible supernova remnant is probably out of the question. Well, this is kind of where this new research comes in. A more thorough analysis using various tree ring deposits, trying to model what might have happened here. With one of the first and one of the more important discoveries in the paper suggesting that these tree rings don't actually correlate with the typical sunspot activity. And here they didn't just look at one event, they've actually taken a look at several that we discussed in that previous video that you can find in the description, with several major events already discovered in the last 10,000 years. Suggesting that these events, whatever they were actually happening independent of the solar activity. Now normally when it comes to solar flares, we expect them to happen in a kind of a predictable manner. For example, during the peak of the solar activity when there are a lot of sunspots, we expect some of the most powerful flares. But in this case, the spikes in radiocarbon were happening when the solar activity was more or less weak, and certain spikes even persisted for multiple years. Something that's even apparent in this graph right here. And so unless our sun was for some reason active for several years straight, it would be very difficult to explain this using the sun. Then there is also a discrepancy between various rings coming from various regions. In some regions, they showed an extremely sharp spike that happened very suddenly, whereas other regions were actually displaying a much slower spike that very likely lasted for 2 to 3 years, hinting that whatever was happening to our planet was probably a much longer event, potentially an event that lasted for a couple of years, and actually some kind of a space event, some kind of a space outburst, or some kind of a space storm that lasted for several years. And it could even be a supernova, but just not a supernova that was visible to us, or at least a supernova that was not detected by ancient astronomers. And there is another video that talks about this in a little bit more detail, but there are certain types of supernova that we've actually just recently discovered that in theory can produce huge amounts of X-ray radiation that would be obviously invisible in optical light, that can actually affect the planet at hundreds of light years away from us, resulting in extremely powerful emissions that would affect the upper atmosphere. On top of this, in October of 2022, we've experienced this, the most powerful gamma ray burst ever that occurred approximately 2 billion light years away from us, that despite the distance actually did have an effect on the upper atmosphere as well, More detail in the video in the description. These events are kind of rare, but a powerful supernova only visible in, for example, X-rays could maybe explain at least some of these events. But in reality, at the moment, nobody really knows what kind of happened here, and a lot of these events are still completely unexplained. It could have been a powerful supernova or some kind of a powerful astrophysical event that we do not understand yet, or it could have also been a super flare coming from the sun, an event that we don't actually think our sun is capable of, but obviously we could be wrong, or more importantly, it could be something else entirely new, something we actually do not know anything about. Right now, based on all of the observations and all of the analysis here, there's really no single simple explanation that kind of explains exactly what happened in the last 10,000 years to produce these very powerful events. But understanding these events would be very important. Current analysis suggests that these happen at least once every 1,000 years. There's actually approximately 1% chance that we're going to be seeing one in the next 100 years or so. And so it's not an impossibility, and if it does happen, it would affect us quite a lot. As a matter of fact, this particular study that examined an event that happened 9,000 years ago discovered something even more powerful. And another event was found approximately 200 years later in 993. So they do seem to be kind of random, which creates a bit of a problem, because it probably is not from the sun. Our sun is a little bit more predictable than that. And so if it is coming from some kind of an astrophysical event, some kind of a major explosion, or possibly even a supernova, that would make it a lot more intriguing, because it means that we definitely don't understand what effects these have on our planet, and it would also mean that we need to study this as soon as possible. This could actually happen to us in the next few decades, having quite dramatic effects on our technology and on our way of life. But just to clarify, even though the radiation levels here increase quite a lot, it would not actually affect the life on the planet that much. In other words, it's unlikely to produce effects that would cause some kind of an extinction event, or increase the dangerous radiation reaching the surface and thus affecting life that way. That's very unlikely to happen. But then again, the spike was still pretty big, and so what actual effects it's going to have on the planet, I guess only time will tell, when it actually happens. This is definitely not the question of if, it's a question of when. And if by then we start traveling across the solar system and start interacting with the outer space a little bit more, an event of that power would definitely produce huge amounts of radiation for anyone in outer space, destroying a lot of technology in the process. So if we do become a little bit more advanced when it comes to interplanetary travel and possibly start settling the Moon and Mars, this type of an event is definitely something we need to be concerned about, because it can potentially destroy everything we've built in space. Nevertheless, these Miyake events, as they're known, currently represent some of the more mysterious and potentially dangerous events that can happen to our planet that we basically don't understand almost at all. Hello wonderful person, this is Anton, and today we're going to be discussing a new mystery. And here's what it actually kind of looks like. The scientists currently refer to this as Sauron. Yep, the same Sauron from Lord of the Rings. Although in this case it's a bit of a play on word, and it's actually an acronym. It stands for Steep and Uneven Ring of Non-Thermal Radiation. And at the moment it seems to be the first such object discovered in all of the data, but at the same time it seems to be somewhat similar to another very unusual phenomenon only discovered back in 2019. An extremely strange phenomenon referred to as ORCs, odd radio circles. The unusual radio phenomenon we've discussed a few times on the channel, and that even today still doesn't really have a very good explanation. But it seems to be absolutely giant, potentially several million light years across, and just as the name implies, it's only visible in radio light. It's invisible in the X-rays, it's invisible in optical light or the infrared. And there's a very limited way how these particular radio emissions can actually be produced. As a matter of fact, the only potential explanation here is what's known as synchrotron radiation, which usually happens when things like, for example, electrons suddenly change the direction of motion, most often because of magnetic effects, and then emit radio light as a result of this change of direction. Nevertheless, after 4 years of investigations, and 6 such objects discovered so far, we still don't really have any explanation of what's actually happening here. All of these ORCs, or odd radio circles, are bright in radio waves, but only 3 of them seem to contain optical galaxies in their centers. So maybe at least 3 of them were actually formed by galaxies. How the other 3 were formed is of course unknown. But back in 2019, even the detection of these objects was already a huge mystery. nobody ever expected these objects to be discovered, and they were actually discovered completely by accident. In this case, the data came from the Australian Square Kilometre Array, the super powerful radio telescope currently operating in Western Australia. And so in that data, the scientists discovered several unusual objects approximately 1 arc-minute in diameter at very high galactic altitudes away from the galactic plane, with all of them resembling some kind of a spherical shockwave. But no current explanation, such as, for example, neutron star collisions, black hole collisions, galactic collisions, supernova, gamma ray bursts, or any other common emissions we usually detect, could explain what's actually happening here. And so in the end, the scientists realized that orcs must be a completely new type of an object and were basically the biggest mystery in astronomy, at least the biggest radio mystery. Even things like fast radio bursts had a few more explanations compared to orcs. But we obviously have more telescopes coming, including the giant Magellan telescope and the currently active Meerkat telescope located in South Africa, which of course means that we're getting even more data, radio data, that can allow scientists to discover even more of these unusual objects. And that's pretty much exactly what kind of happened here, except that there's one problem. New telescopes, new observations, also mean ridiculous amounts of data. Here, just a single observation from the Meerkat can actually result in terabytes of data that then has to be analyzed by someone. And even though this is open to volunteers, normally not a lot of people actually are able to do so effectively, and normally most of the data ends up being unprocessed. And so the scientists behind this study came up with their own artificial intelligence, or I guess technically machine learning. They named it Anomaly, I guess combining astronomy and anomaly. An algorithm whose main purpose is to go through data and quickly find out something unusual inside the data, something that just doesn't make sense, and specifically data that might have been overlooked by others. In this case, applied to the data from the Meerkat collected in the last few years. And, well, it did find something. And I think the title from the paper basically says what it is. A unique ring-like radio source with quadrilateral structure detected with machine learning. Basically, this. But because the previous objects were orcs, they decided to name this one Sauron. Which I guess means that all of the future radio discoveries that involve mysteries are probably going to have some kind of a Lord of the Rings reference as well. And I can't wait for someone to name something Morgoth, Melkor, Shelob, Balrog, and of course, Frodo. Because, well, it's Frodo. And also apparently I look like him. Anyway, I'm actually super excited about future discoveries and future naming. As a matter of fact, maybe there should be a rule where any object that involves radio waves and is unexplained has to be some kind of a character or a thing from Lord of the Rings. Yeah, probably not gonna work. But I'm still going to be using these names anyway. And so they named this Sauron. But even though it might sound kinda cheesy, it does have a meaning behind the name. S stands for steep. In this case referring to the unusual spectral slope where the high radio frequencies very quickly grow fainter as they move away from the source. But UR in this case refers to uneven ring. That's because it's not a perfect ring, unlike a lot of other odd radio circles. And the last part refers to non-thermal radiation, referring to types of radiation produced by particles accelerating by powerful magnetic fields, but possibly not by anything else, because nothing else seems to be happening here. And currently this object is believed to be about 1.2 million light years across, 20 times the size of the Milky Way galaxy. But the question is it also an orc? Is it an odd radio circle? Well, at the moment it doesn't seem to be the case. It doesn't really have the same properties as odd radio circles. For example, with a lot of orcs, at least half of them do have a central galaxy in the middle. Here, however, the host galaxy known as Abell 209 does not seem to have any radio emissions like the ones where we usually find orcs. And more importantly, none of the wavelengths or the frequencies match the observation from Sauron. At the same time, its shape is very different as well. It's not really a circle. And as the name implies, it's basically four-sided, quadrilateral, which to the scientists behind this paper suggests that the magnetic field in this case might actually have some unusual properties. The fields here don't seem to align well with the main structure, and so its true origin is completely unknown. And even though it resembles one of the odd radio circles a little bit, they're still very different from a lot of other discoveries to date. And at the moment this seems to be one of approximately 200 different anomalies identified by the artificial intelligence, but only one of them resulted in something that seems to be definitely there. The only problem is that we don't really know what it is. Is it the result of a galactic collision? Is it a result of a black hole collision? Or is it something entirely different? There's really no way to actually know what it is just yet. Although at the moment, the best explanation so far is that maybe it is a result of a merger between two supermassive black holes millions of years ago, specifically located right in the middle of Abell 209. But in order to actually establish if this is what happened here, we have to find other signs. Usually these also involve a lot of emissions, including a lot of star formation, and very powerful accretion disks around a central black hole. At the moment, nothing like that has been discovered here just yet. But the only explanation for what we're seeing is really powerful magnetic fields. No other physical phenomenon can create anything like this without producing other emissions. There's no optical light, there's no X-rays, there's no gamma rays, there's nothing. Just radio light. So it has to be a very powerful magnetic field, but in this case a field that stretches across millions of light years. But then again, that's pretty much exactly the same problem with trying to explain orcs. We still don't really know what happened here either. I guess the only difference is that these are a little bit more circular, and usually are actually associated with some kind of a galactic center. This, however, is not. But chances are we're not going to know what it is anytime soon. This thing is about 7 billion light years away from planet Earth, so it is actually pretty far, and even the most powerful radio telescopes right now are going to have trouble discovering what actually happened here. And this was also the only discovery out of approximately 115 galactic clusters, with each containing thousands of galaxies. The observations here lasted for approximately 1 year, which basically suggests that these are not very common objects, the only one out of potentially 100,000 galaxies investigated so far. And so whatever is happening here is just going to be yet another radio mystery to add to the book of various other radio mysteries discovered in the last few years. Hello wonderful person, this is Anton, and today we're going to be talking about this relatively recent detection of a somewhat unusual radio signal that we've talked about a few months ago, and a recent paper that potentially finds a pretty good explanation for what this actually was. At least the best explanation we have so far. And so I wanted to talk a little bit more about this particular signal, what was actually discovered a few months ago, and also talk about the explanation from this paper. But let's start with the detection of this unusual radio transient, originally found back in 2020, but recorded by the radio astronomers back in 2018. With the data coming from the Murchison Wide Field Array that you see right here, which is essentially a collection of various radio antennae located in Australia. And so back then, when the scientists were looking at some of the data and creating these beautiful radio maps, they've actually found something that they didn't expect. Something coming from the region you see right there. Or if you were to look at the Milky Way galaxy in the optical light, it would be right here. Something in this region was pulsating, producing a lot of brightness in radio waves, staying bright for approximately 30 to 60 seconds, but pulsating every 18.18 minutes. Actually being the brightest radio object located in the night skies at that point, specifically in the frequency of 70 to 215 MHz. And although obviously this is not the first time unusual radio signals were coming from somewhere out there in outer space, this was the first time ever that the scientists discovered something so extremely bright, but something that seems to pulsate extremely slowly and produce very unusual and very difficult to explain emissions that were just never seen before. With this object eventually acquiring this relatively long name and becoming one of the bigger mysteries in radio astronomy. But I guess what made it even stranger is that after a few months of pulsating at regular intervals of just over 1,000 seconds, it suddenly disappeared and never really reappeared ever again. And so because of this was that unresolved mystery of a very unusual radio signal that the scientists have been trying to resolve for almost 2 years. But obviously, this is not the only radio mystery out there. As a matter of fact, we've talked about so many other radio mysteries in the last few years, and this is of course because the radio observatories and radio astronomy has actually improved so much now that we've been detecting a lot of things that nobody ever expected. We have things like fast radio bursts, we have things like orcs or odd radio circles, and a lot of other things we discussed on the channel. But in this case, this signal was unusual for other reasons. So first of all, normally when we see periodic radio signals, we generally assume that it's maybe some kind of a pulsar. essentially a neutron star that spins at regular intervals, usually once every second or actually once every few milliseconds, and generally as it does so, it will then produce these jets visible from extremely far away, with the jets being in radio light. But the difference here is, well, you can see it right here. Normally, a pulsar spins very fast. This object spins super slow, every 18 minutes. At least according to these observations for a few months, where everything was repeating every 18.18 minutes. And because of this, the initial assumption here was that, well, maybe it's some sort of a extremely highly polarized magnetar, or a neutron star with a very powerful magnetic field, the most powerful magnetic field in the universe, as a matter of fact, which essentially was spinning very slow because of the magnetic field. And here it would be what's known as the ultra-long period magnetar, a type of an object that we've actually never seen before. And because light coming from this object was also highly polarized, the signs of a very powerful magnetic field coming from this region were clearly there. But one of the problems with the magnetar as an explanation was the fact that, well, first of all, there was no known mechanism to explain why it suddenly disappeared after a few months, and also that the actual emissions were just a little bit too bright for a typical neutron star. If this was a neutron star, the scientists expected it to be a little bit more dim. And on top of this, the suggestion here was that, well, whatever is generating these periodic signals seems to have very different process from a typical pulsar or a typical neutron star. It just didn't possess the same type of a signal we usually observe from pulsars we've discovered in a galaxy. And also, as a quick side note, this is not the only unusual repeating radio source coming from the region around the central galaxy. There are actually several different so-called GCRTs, or the Galactic Center Radio Transients, that have been found in the region where we normally expect the center of our galaxy to be. With some of them visible in this image right here, with this region here representing the actual center. But those radio signals are also different in their profiles and might be entirely different types of objects as well. So basically some other mystery we've discussed before and we'll talk about in some of the future videos. Which, by the way, is probably the reason why you should subscribe. And on top of this particular signal seemed to be a lot closer, approximately 4,000 light years away from us, as opposed to 15 to 20,000 light years away as those other signals. But there was always this third explanation that the scientists kind of assumed at first, but weren't really sure about. In this case, it did not involve any neutron star, but involved what's known as a white dwarf, the same type of an object that our sun is going to become in a few billion years from now. Now, in theory, a white dwarf can actually have certain properties that can allow it to have very powerful magnetic fields, but also produce certain types of radio light. But the thing is, it was always sort of very theoretical. The actual observations were lacking. And there's actually only one potential object that might be a radio dwarf that was discovered a few years ago, the object we refer to as the white dwarf pulsar, but in this case the mechanism by which it produces radio light and all of the emissions, as you can see in this video, is very different. There's a binary system here, and it seems to actually affect the star next to it as well. Nevertheless, the system of AR Scorpii has always been that one potential source of unexplained radio light. But in this case, it was all powered by the partner star, so basically this would be a binary system. Yet the observations from this particular region did not suggest any binary partner, at least not through the emissions detected so far. Which leaves us with the only potential explanation that has been suggested but never found. So it could be that singular object, singular white dwarf, that possesses very similar to a typical pulsar features. Or, as the scientists have always referred to these, a white dwarf pulsar. An object that nobody has ever seen before, but also the object nobody expected to be so extremely bright. At least in radio light, it's not actually bright in visual light, and so even by looking at this with an optical telescope, it's very unlikely that we would see anything. And if this is such an object, it seems to possess an extremely effective way of converting the magnetic energy into radio light, and seems to do so much more effectively than any other object we've seen so far, including neutron stars. With the main reason behind the study and the main explanation behind why this is a white dwarf and not a magnetar being in regards to the polarized light detected coming from this object. The actual observations suggest that the magnetosphere here was very similar to a white dwarf, not to a neutron star. with the calculations focusing on what's known as the Lorentz factor, the concept from the theory of relativity that sort of focuses on how much, for example, time or length of an object changes depending on how fast it travels, or depending on how much the gravity sort of folds the time-space around something. And in this case, we expect different observations from a neutron star compared to a white dwarf, with the new calculations suggesting that whatever it is, it's not as dense and as potent as a magnetar. Seems to be probably a white dwarf. And because white dwarfs are also generally a little bit brighter than neutron stars and in theory could be seen with a powerful telescope, by using some of the more powerful optical telescopes, including the James Webb Telescope, it could become possible to maybe identify this object for sure, and more importantly, all of its other properties, including how it's able to generate the magnetic field and how it's able to produce these radio waves we're observing. And so in other words, we could prove all of this by conducting some of the more advanced optical observations of this particular region. But I guess until future observations or future analysis or possibly future studies, that's pretty much all we know right now. Hello wonderful person, this is Anton, and what you see behind me is a kind of a representation of Betelgeuse, because once again we're going to be talking about this unusual, mysterious star. Because it turns out that it's doing something else once again, and something nobody can explain because it doesn't really make sense. With all of the recent observations, once again maybe suggesting that either the star is just really unusual and there are a lot of physics here we don't understand, or maybe, fingers crossed, it goes supernova, creating a very spectacular view in the night skies, but very likely not affecting Earth that much. And so let's discuss exactly what's happening here, but first, a bit of a catch-up. What exactly happened to Betelgeuse back in 2019? The star that you see right here, visible from one of the solar probes because it's just ridiculously bright. It's one of the brightest stars in the night skies, but also one of the largest ones we've seen so far, and it used to be a record holder up until more recent discoveries. You can find out what star is currently the largest in one of the videos in the description. But interestingly, unlike our star, Betelgeuse is extremely young. It's only approximately 10 million years old, and it's actually expected to go supernova anywhere from a few thousand years to maybe a few 100,000, depending on who you ask, and depending on what model the scientists are using. And so this object is definitely very close to its end times, and is expected to be one of the first stars to go supernova near us. Although near is a bit relative. It's anywhere from 550 to 640 light years away from us, so it is kind of far away. And the reason the scientists are not certain about the distance is because it's kind of difficult to determine certain properties of the star, for example its overall size, which can then help us determine how far away the star is. One of the recent papers from I think a couple of years ago even suggested that the star might be a little bit closer to us, so just over 500 light years away. But despite the distance, it's still really bright. It's anywhere from 7,000 to 14,000 times brighter than the Sun, and is in top 10 brightest stars in the entire night skies. It's also currently approximately 700 times larger than the Sun, with the overall mass of 15 solar masses. But it's not as hot as the Sun. The temperatures here are much lower, possibly just a little bit more than 3000 Kelvin, because the star has expanded so much. But intriguingly, even some of the older astronomers were aware of its unusual properties, specifically its ability to change brightness. The brightness change was even documented by Sir John Herschel, one of the more famous astronomers of the 19th century. Although that's not unusual, these are known as variable stars, and there are quite a lot of them out there. This is actually very common in a lot of larger stars. But intriguingly, if you look back in history, there are even discoveries about the description of the star from various Aboriginal Australians, or even more recent descriptions by various Arab astronomers or Chinese astronomers that didn't just describe the star, they actually wrote everything down. Even Ptolemy described the star by using a very specific Greek word, the word hypokeiros. Totally mispronounced, leave your complaints below. But the point here is that this particular description applies to colors that are sort of orangey, not really red, or basically pale yellow to light reddish, and somewhat different from the color we see today, which implies that the red color we're observing from it in a lot of modern pictures is something that happened in the last 2000 years. In other words, the star is evolving pretty quickly, and it seems to have at least two different cycles, 400-day cycle and a cycle that's a little bit longer at 5 years, which is exactly what the scientists have been observing for the past 200 or so years. But in 2019, something suddenly started to happen. It dramatically decreased in brightness by approximately 60%, becoming a much dimmer star than anything we've ever seen. Here are the actual observations from this period, and you can see that January 2019
was much different from January 2020. But by March 2020, it returned back to normal. If you like graphs, here's what it kind of looks like on the graph. And so this unusual great dimming event remained a kind of a mystery up until relatively recently, and all of the additional observations suggested that for some reason, Betelgeuse suddenly exploded, expelling a huge amount of material that after cooling down covered the star, decreasing its overall brightness from our perspective. In other words, the star itself might have not really changed that much, but that dust cloud covered the star. There's actually a really intriguing explanation you can find in one of the videos in the description that even suggests it could have been a result of a planetary collision or essentially a planet being absorbed by the star, with this new phenomenon now referred to as a surface mass ejection. It's not super clear what caused it, but it's the best explanation we have so far. And intriguingly, the calculations suggested that the entire dust cloud here was probably several times more massive than our moon. Or essentially, this ejection was approximately 1 trillion times more powerful than anything the sun can produce. So the obvious question was, how common is this, and what exactly caused it? But the preliminary investigation suggested that it's unlikely the star was going to go supernova anytime soon. Or is it? Because just a few weeks ago, the scientists have now noticed something else. The opposite. Betelgeuse has now increased in brightness by approximately 42%, and possibly as much as 50% from its average. And as you can see from this graph, from a wonderful person, Remy Mandau, whose tweet you can find in the description, it looks like this has been happening for the past few months. Which raises another question about the star. Why? What's happening? What's going on? It really seems to be doing stuff we've never seen anywhere, and it seems to be producing effects that we currently cannot explain. And even though technically we don't understand what happened back in 2019, we really don't understand what's happening now. And this unusual rebrightening cannot be explained by a dust cloud. And so whatever it's doing, it seems to be doing on the inside or at least on the surface of the star. And because of its increase in brightness, it's technically now the 7th brightest star. It's even brighter than Procyon or Rigel that used to be much brighter. But I guess more importantly, there is no theoretical explanation for what's happening on the surface or for what's actually causing this. I guess there's maybe one potential explanation. Maybe whatever happened back in 2019 is now sort of reshuffling the surface of the star, with the top layers that were disturbed back in 2020 now coming back to normal by essentially dimming and becoming brighter over time. Or basically it's reshuffling its surface. But that's just one speculation and there is really no evidence for anything just yet. Although maybe there is a way to confirm what's happening by using some of the telescopes we currently have. For example, the Hubble telescope, or even the balloon telescope known as SuperBid, the video about which you can find in the description, might be able to resolve certain details on the surface, explaining what's actually happening here and why the star is changing brightness. For now though, new mystery, more unexplained observations, and I guess more importantly, a potential chance for, maybe, Betelgeuse to go supernova. Although in reality we're not actually going to know if it's going to go supernova until pretty much the last second. And that's because when stars do go supernova, they give us very little notice. A typical luminosity graph would look something like this. In about 30 minutes it would suddenly become quite bright, would then experience a sudden dimming for a few minutes, and then would continuously increase in brightness for a couple of weeks to possibly a month. This is something we've observed from various supernova. And also, various neutrino detectors that usually detect 1 or 2 neutrinos here and there will suddenly receive a burst of millions and millions of new neutrinos as they escape the star and as they start to interact with matter on planet Earth. But chances of this happening right now are pretty slim. It's still very unlikely that Betelgeuse will go supernova, and it's a lot more likely that this is just another mystery we don't understand in regards to red giants. So yeah, looks like scientists discovered even more unusual supernova nobody knew existed or could even be possible. Hello wonderful person, this is Anton, and today we're going to be discussing 2 such discoveries about 2 potentially new phenomena, at the moment impossible to explain. With both of these unusual phenomena discovered just weeks apart, from 2 completely different types of stars and completely different parts of the universe. Let's start with the first one. This first one is an unusual type of an explosion that we actually cannot explain at all. It seems to be a supernova, but it could be something entirely different as well. So basically here, the explosion was extremely bright and it suddenly brightened very quickly, yet unlike a typical supernova, then dimmed really quickly as well, disappearing into nothingness. Now normally in a, for example, type 2 supernova, you'll have a star collapsing,
exploding, brightening for a couple of weeks, reaching the peak of brightness after maybe 14 days, and then slowly dimming over time. If you like graphs, here's roughly what the graph looks like for a typical Type 2 supernova. And this can actually last for a few months. As a matter of fact, one of the recent supernovae that was detected not so long ago, in one of the nearby galaxies, about which you can learn in the video in the description, was visible inside the pinwheel galaxy for many months afterwards. And so this is usually what we expect from a regular explosion. And generally most of the curves we observe are usually very similar. And this is independent of if it's Type 1 supernova or Type 2. With most of these supernovae reaching their peak after approximately 20 days. This is of course on average. And they usually become at least several billion times brighter than the Sun. But they obviously dim with time and usually disappear completely after 1 year. And pretty much every single year, hundreds of different supernovae are discovered across the universe, with most obviously being very far away from us. There hasn't been a single supernova in the Milky Way galaxy for quite some time. And now we have this unusual new event you see right here. Within just 10 days, it became ultra bright, approximately 100 billion solar luminosities. Much brighter than a typical supernova. But then, within approximately 15 days, it faded almost completely. It was only about 1% as bright. And so because it became so bright and actually reached this brightness so quickly, and then dimmed so quickly as well, scientists are now proposing this to be a new type of a phenomenon. Luminous fast coolers, LFCs. Potentially a new type of an explosion we've never seen before, representing some kind of a super destructive event that seems to be brighter and more powerful than a typical supernova. But also maybe not being a supernova at all, mostly because of its location and because of a lot of other observations. For example, first it was discovered in a galaxy that you can sort of see right there, that mostly contains extremely sun-like stars that are not really massive enough to produce a supernova. You need to have a star of at least 8 solar masses for any of this to happen. Now it could be a Type 1 supernova involving a white dwarf, but it doesn't really match these types of explosions either. And more importantly, it happened in a massive red galaxy, or basically elliptical galaxy with a lot of odd stars, and very far from the center, as you can see right here. We don't really expect to have any large stars in this region of an elliptical galaxy, and even comparing this to other famous explosions, nothing here seems to match. Now, it's not the brightest explosion out there, there are some even brighter ones, but it's definitely in the league of its own. And definitely fades much quicker than anything else. But even more importantly, when they look at the older archives, they discovered 2 more such explosions, one detected in 2009 and one in 2020, that were just missed by previous studies, with scientists assuming these were supernovae as well. These were also in similar galaxies and in strange locations. And because 3 such events now have been discovered, scientists behind the study assume that this is some kind of a new phenomenon that we need to understand and try to figure out. Not maybe a supernova, but something maybe involving maybe a black hole, maybe something else. For example, one assumption was that maybe this is a result of 2 stars colliding and essentially exploding as a result. Now that's possible, but it shouldn't be that bright. Another explanation involved a black hole. Now this cannot be a supermassive black hole, because once again this is happening on the outskirts of the galaxy, so we don't expect these objects to exist here, but it could be a smaller intermediate mass black hole that maybe swallowed a star. We've actually seen such event a few years ago, a video in the description talks a little bit more about this, but in this case this is known as the tidal disruption event, and we expect to see X-rays, or some kind of a higher radiation. Nothing like that was discovered here either. And so maybe this was a black hole collision or some kind of a black hole shredding, because usually this happens really fast and does involve a lot of brightness, but done in a different way where X-rays are just not produced. So yeah, at the moment nobody knows what's happening here, or what's creating these unusual events in galaxies where they should not happen. Now this event is now officially known as Atom because of the random assignment of letters when it was originally discovered, and so Atom is now a new type of an event. At least for now, we're going to be calling them LFCs, luminous fast coolers. But they'll probably become a little bit more easier to understand once we find even more of them using other surveys, especially if one of them can be found much closer to Earth. The ones in this study are really far away, millions of light years away from planet Earth. But apart from Atom, or apart from these LFCs, there was another unusual discovery from much closer to home. And this time, it was an observation that was detected almost right away from a small dwarf galaxy that you see right here. But in this case, it appeared to be a Type 1 supernova, meaning that this is a supernova involving a white dwarf that acquires enough mass by stealing this mass from its partner. And once it crosses what's known as Chandrasekhar limit, or basically once it becomes approximately 1.4 solar masses in mass, it explodes because at this point it reached its limit. All Type 1a supernova seem to happen the same way, at least for the most part. But the examination by two separate teams that released two separate studies revealed something really strange here. And interestingly, both of these papers came out on the same day, pretty much about the same object, and discovered the same thing. So here's what they found. They now believe this is a supernova that possibly detonated twice, a double supernova. And specifically, it was a strange Type 1a supernova that did not involve Chandrasekhar limit. Or in other words, unlike previous supernova with white dwarfs, where they explode because of the mass limit, in this particular case, something else caused the supernova to happen, and the white dwarf was not at its limit. So basically, it was a very unusual, very peculiar supernova that has never been seen before and surprised a lot of scientists. But there is now a really good explanation. Despite the distances involved here, and despite the fact that this is a dwarf galaxy, this double detonation provided enough information from different elements in this explosion for the researchers to make specific conclusions about what they think happened here. And unlike the previous LFC supernova, this one was actually much dimmer than usual. It was what's known as subluminous supernova. And so one of the telltale signs here to try to explain this was an unusual observation of a sudden explosion of red light that happened 11 days before the major explosion. But even though that red explosion did appear kind of unusual, the second explosion resembled a typical Type 1a supernova. So in other words, we have this unusual double peak. And the main explanation here involves what actually happens around these star systems as the white dwarfs accumulate all of the mass around them by stealing it from their partner. And so here usually the white dwarf starts to acquire a kind of an atmosphere on top of it, as it basically steals the mass from the partner star. Now in most systems when this happens, this is usually hydrogen, and occasionally it reaches the limit where it detonates, forming what's known as nova. These are actually super common and they happen everywhere, including the Milky Way galaxy, with many of them happening every few years. We usually refer to these stars as cataclysmic variables. But in certain binary systems, if the partner star is different, you'll actually have different elements on the surface. And so it's now believed that this star was probably filled with helium. And so the white dwarf started to deposit a lot of helium on its surface, forming a huge helium shell instead of typical hydrogen. And once that helium shell was formed, it once again reaches a certain limit, triggering what's known as helium detonation. This happens because there's just so much helium on the surface and it's so highly pressurized and so hot that it starts its own nuclear reaction all at once. And this powerful helium detonation always forms what's known as nickel-56, which was actually observed coming from this particular star system. So this was a telltale sign that helium exploded here, at least in the beginning. This is probably what produced that red emission 11 days prior to the main explosion. But this explosion of helium doesn't just produce nickel, it also creates a shockwave going inside the white dwarf. And it's quite likely that it's that shockwave that suddenly triggered the second detonation inside the star, basically ripping apart the white dwarf, initiating Type 1a supernova, even though the mass limit was not yet reached. And so it was that helium detonation that produced nickel that then also caused the star to suddenly explode, disappearing in the process. With the analysis now suggesting that the white dwarf was probably about 1 solar mass in total, and the helium shell was approximately 2% of the solar mass, explaining the overall observations and overall emissions seen in this supernova, making this one of the more unique, one of the stranger supernova we've seen in the last few years. Although here it would be interesting to see what other elements this might have produced, Because today we do believe Type 1a supernova usually produce huge amounts of different heavy elements and are responsible for enriching galaxies, helping them evolve over time. Hello wonderful person, this is Anton, and today we're going to be talking about a relatively recent study that might have discovered the first ever sign of what seems to be some kind of an ancient supernova that may have happened in what's known as extragalactic or intergalactic space, somewhere on the outskirts of the nearby galaxies Large Magellanic Cloud and Small Magellanic Cloud. And if confirmed, would represent an extremely interesting discovery because we don't generally expect supernova to occur away from certain regions of the galaxy, requiring some kind of an unusual exotic explanation. And so let's talk a little bit more about this particular discovery and what the scientists using various Australian radio telescopes discovered in the last few years, and why we're actually able to see so many different new mysteries across the universe because of these various telescopes that have become so extremely powerful that they're able to see things we've never been able to see before. With all of this connecting to that other mystery, the mystery of orcs or odd radio circles that we've discussed in one of the previous videos you can find right there or in the description. In that video we've discussed the potential explanation and the new discoveries in regards to these very strange formations across the universe. These very peculiar objects that seem to be millions of light years across, but seem to be only visible in radio light. They don't produce any X-rays, they don't produce any infrared light, they don't produce any optical light. And so since their original discovery a couple of years ago, they've been simply referred to as odd radio circles. Discovered by a network of very powerful telescopes such as the Australian Square Kilometre Array Pathfinder, and later confirmed by other telescopes such as the South African Meerkat. With the telescopes eventually establishing that, well, these very distant orcs, for the most part, seem to be sort of centered around very distant galaxies which might have produced extremely powerful explosions for one reason or another. Their actual origin is still not entirely clear, but what's clear is that these objects are really huge, and most of them generally have some sort of a galaxy right at the center, which very likely produced them. But not all orcs were created equally. As a matter of fact, several orcs discovered in the last year or so, such as of course the one in this study, did not really have anything in their center, and to some extent also possessed slightly different features, with some of them also being in the middle of nowhere next to pretty much nothing, which naturally presented a bit of a new mystery. It meant that certain orcs, certain odd radio circles, were even odder, or basically represented an entirely different way of producing similar objects. Which is precisely what this new study by the same scientists behind the orc study decided to tackle, and wanted to find out exactly what some of these other orcs represent. And since one of the original explanations in regards to orcs involved various supernovae which normally do produce these spherical or somewhat circular formations, which sometimes can also have a lot of radio emissions coming from within them, the scientists in this case wanted to find out if it was possible for at least some of these orcs, the ones without anything in the middle, to be supernova remnants. With this object right here being particularly interesting for at least two more reasons. First of all, it seemed to have a very unusual flat radio spectral index, suggesting that it might have had slightly different origin. Basically, its radio frequency was a little bit different. And secondly, compared to other orcs, it actually appeared to be larger, which suggested that it could have been much closer to us than anything else we've seen so far. But trying to understand how this object was created and what exactly it represented was very difficult for one simple reason. It didn't seem to have anything next to it, and it didn't have anything in the middle. As you can see from this image, it seems to be pretty much completely isolated by itself. And at least in terms of appearances, potentially being somewhere between the Large Magellanic Cloud and the galactic plane of the Milky Way galaxy. So somewhere right here in the region you see on the screen, possibly in the middle and possibly a little bit closer to the Large Magellanic Cloud. But because it's kind of difficult to judge distances in space, especially if there is no other indication or no other representation from other frequencies, in this case the scientists were sort of at a loss on how to approach this. So basically they decided to make all of the potential propositions of what could create this object, and then reject these propositions one by one based on what they were seeing. So first of all, because there was no galaxy in the middle, this was unlikely to be a typical odd radio circle like the ones we've seen and talked about before. It was also unlikely to be some kind of a gigantic star flare or any other star emission, simply because it would probably produce other radiation as well. And it was probably not a quasar or microquasar or a distant active galactic nucleus or any other powerful galaxy, simply because it didn't really produce X-rays and gamma rays either. So once again, in this case, something else must have been happening in this particular region, with basically the only logical explanation left to the scientists being a supernova remnant, because we know that they do produce relatively circular formations and they can produce a lot of radiolight, with certain types of remnants potentially only visible in radiolight as well. As a matter of fact, if you were to look at a typical radio map of the Milky Way galaxy, you would actually see quite a lot of various circular objects across the galactic plane, and every single one of these galactic circles is a remnant from a supernova. And the majority of them are not visible in other frequencies. Nothing in the visible light, nothing in the gamma rays, and only some of them are visible in X-ray. Suggesting, of course, that certain supernova, in theory, could produce radio emissions only and could produce these very large radio circles. But the problem in this case is that normally we expect supernova to happen only in certain regions of space. For example, in very large, very massive molecular clouds, or other regions of space with very powerful, very massive stars, maybe certain globular clusters, or various regions of space with potentially really massive stars, a lot of starburst regions. But these regions never exist between galaxies, they're never in the intergalactic space. So how exactly did a supernova happen here? Well, in this case, the scientists believe that there might have been actually some kind of a star, or potentially a binary star system, residing in the Large Magellanic Cloud. And this star system, which very likely had two stars that were slightly different in mass, most likely had two stars with a lot of interaction between one another. First, one of the stars very likely lost its outer shell and turned into a white dwarf. Then, sometime later, the other star also started doing the same, with eventually both of these stars becoming orbiting white dwarfs that started to come closer and closer to one another until one day they basically collided, reaching the Chandrasekhar limit and exploding as a Type 1a supernova, although more specifically this is actually known as the Single Degenerate Progenitor Supernova, with the event itself occurring at a relatively far away distance between galaxies. Now, why exactly these stars were so far away from the Large Magellanic Cloud and from the Milky Way is not really a question we can answer, but stars do get kicked out of various regions in the galaxy all the time, with the actual explosion happening anywhere from about 2200 to possibly about 7000 years ago, with the remnant itself already being approximately 155 light-years across, making this a really large supernova remnant, which would also explain why we don't really detect many other frequencies from it, simply because it's already sort of disappearing into nothingness. And although normally a lot of supernova remnants are not as perfectly circularly shaped, some are, such as the iconic SN 1987A that's also located right in the middle of the Large Magellanic Cloud galaxy. So it actually would not be unusual for a supernova to have a somewhat circular shape and have all of the features detected from this particular object as well. And, if confirmed, this would be an extremely important discovery. It would be the first intergalactic supernova remnant, and it would also be the first explanation for an odd radio circle formed as a result of an ancient supernova, while also potentially helping us discover what happens in between galaxies when supernovae occur. Because typically, in a normal galaxy, when a supernova does happen, there is quite a lot of density inside the actual galaxy to prevent the supernova from expanding too fast, which often results in very typical supernova shapes that we see pretty much everywhere. But in this case, because this is in between galaxies, this would maybe explain why the shape is a lot more perfectly circular, simply because there is just not enough gas between galaxies to deflect or to stop the propagation of matter from the exploded star. And also, it's not entirely clear if there's anything in the middle and if anything was left behind, such as, for example, a neutron star. And so at this point, it's still a pretty interesting discovery and still a pretty unique mystery. But chances are that it is actually a supernova remnant and the first supernova remnant found between galaxies. So today we're going to be discussing a concept that's kind of tricky, actually really tricky, because this concept is going to involve pretty much everything confusing about astrophysics. It's going to involve black holes, is going to involve the expansion of the universe, and it's also going to involve quantum physics. But more importantly, it's going to involve the reality as a whole. Hello wonderful person, this is Anton, and today we're going to be discussing the study that as always you can find in the description below, that to some extent potentially explains why the reality exists. Or basically why you and I are physical objects that you can touch, you can interact with, objects and things that have properties much different from anything from the quantum world, where things are very undefined and involve concepts like superposition, where an object can actually have all properties all at once. Or, if we use a concept from the everything everywhere all at once, it's the everything bagel. Or basically, how do things turn from the everything bagel to a very specific bagel? Or if we try to describe all of this in more quantum physics terms, it refers to the idea of Copenhagen interpretation of quantum physics. Everything can be described as a possibility, until we're forced to interact with this something, or until it's forced to describe its actuality, and then it becomes a particle. Or in other words, things are an everything bagel until you measure or observe them, or until you interact with them, at which point the bagel becomes something else, acquiring one of its probable states, implying that quantum objects don't actually have any reality or any truth until they're observed or until they're interacted with. Although I guess the more common example in this case involves the cat in the box. The cat, while it stays in the box, is both alive and dead. When you open the box, the state changes. But what the scientists in this case are trying to answer is, what exactly opens the box for all of the particles around us? Or in other words, why is it that this actual cat exists, as do you and I? What causes the decoherence of everything around us? And in this case, by applying certain Einsteinian principles, the scientists in this somewhat hypothetical paper discovered something that could be potentially groundbreaking, if they're of course correct. For example, we know that quantum objects lose their quantum properties as soon as there's some kind of observation or interaction. But let's take this idea a little bit further and try to imagine that the observer is really far away from the object. Or let's just say that this observer is actually maybe in another galaxy, really far away. Well, according to quantum physics and according to pretty much all of the math behind it, this particular particle is still going to collapse because in this case the particle is entangled with the observer. It's going to create what's known as decoherence. And that's despite the fact that this observer could be thousands of light years away. Now it doesn't mean that the light in this case is traveling faster than light, it just means that, for some reason, when the information from one object reaches the other object, the quantum decoherence has already occurred. Or at least according to modern principles of quantum mechanics. Okay, let's go with our bagels again. Let's say this is an everything bagel really far away. But let's say that someone is actually looking at this bagel from a different galaxy. Quantum physics suggests that this bagel is going to assume a certain property and no longer be quantum. It's going to become, for example, a sesame bagel. But let's take this thought experiment a little bit further. What if that observer is somewhere else entirely? What if this observer crossed the event horizon and is now inside the black hole? Well, according to quantum physics, there's still going to be entanglement, but even though the light from the bagel is going to enter the black hole and cross the event horizon, according to Einsteinian's ideas, there's absolutely no way information from the black hole, and especially all of this entanglement information, can then actually escape. Which to the scientists behind this paper created a bit of a paradox. Either quantum physics is wrong, which is very unlikely, or something needs to be solved with the general theory of relativity in order to explain this particular principle. But in one of the previous papers, the scientists behind this idea managed to mathematically solve this by assuming that the event horizon of the black hole itself, or that point of no return that no light can escape, actually starts acting as an observer itself. Or in other words, this right here could be the observer that causes decoherence and causes things to collapse. There was obviously no physical proof and no observational proof whatsoever, but in terms of logic and mathematics, it sort of made sense. But here's the thing though, if the event horizon of the black hole acts as a kind of observer causing things around it to collapse, it suggests that black holes around the universe sort of act like these giant observer eyes, potentially causing the universe to create reality that we know. Or the horizon from various black holes is responsible for creating physical objects and for collapsing quantum effects. And although that's an intriguing proposition, they actually go a little bit further in their recent study. In this case, realizing that these types of horizons, where nothing can actually escape, and things crossing the horizon sort of start violating certain quantum principles, may also exist
elsewhere in the universe. As a matter of fact, the edge of the universe. Because in this case, pretty much in a sphere around us, there's this hypothetical idea known as the edge of the observable universe. Physically, we can actually never reach it, but hypothetically, the sphere around us, with a radius of approximately 45 billion light years away from planet Earth, represents the observable universe. But right at the edge, because of the expansion of the universe, things are expanding faster than light. Or in other words, right at the edge right here, that's another event horizon. Sort of like the inverse of the black hole. This is usually referred to as the Rindler horizon, and more specifically the concept of the Killing horizon proposed by Wilhelm Killing to explain some of these observations. And I wanted to clarify that it's named after a person and not because it's killing anyone. And the idea here is that these horizons around us produce very similar decoherence of quantum states. Or the edge of the universe that's around us causes all of these everything bagels in the universe to become something else. Maybe a sesame seed bagel. Or to rephrase this even more, the edge of the universe acts as a kind of an observer of everything inside of it, especially at the center. And so even though this sort of resembles an eyeball, it sort of acts like one, observing everything in the middle and causing quantum particles to assume shape, to assume properties, and to create objects, or to create the reality we know. And by itself, this does sound somewhat metaphysical, and erroneously can start bringing in the idea of, for example, religion. Does that mean that this is basically God? Well, according to the scientists, it's really quite the opposite. It does not mean that the universe is conscious, or that it represents some kind of a godly being. Instead, it seems to provide an exact objective way that causes quantum states to create physical objects, relying on principles from Einstein and from quantum physics. And more importantly, potentially providing a link to both that one day could explain everything around us, assuming that this is correct. It's still very theoretical, very hypothetical even, with all of this based on our current understanding of black holes. The objects that, for all we know, could be entirely different, especially because we know that infinity does not exist, but current mathematics behind black holes involves infinity inside the black hole. This is known as the singularity. Nevertheless, this is a really intriguing explanation that essentially suggests that the coherence of the entire universe is really due to various types of radiation, for example various photons or hypothetical gravitons, coming from the edge of black holes and from the edge of the universe itself. And so if the universe was not expanding so fast, or if black holes did not exist, neither would we. That by itself is somewhat mind-blowing. But I don't think we're going to actually know much more about this other than making this an intriguing explanation to the entire universe and everything around us, until further understanding of black holes and further understanding of what actually happens right at the event horizon of these unusual objects and what happens to things that enter black holes. That's not something we can answer anytime soon.
Hello wonderful person, this is Anton, and today we're going to be talking about a potential solution to one of the mysteries in the universe. The strange galaxy that you see somewhere right here. It's actually really hard to see. A galaxy that's around 320 million light years away from us, and a galaxy that seems to possess a lot of mass on the inside, yet not enough stars. A galaxy that's also known as Dragonfly 44, named after the telescope known as Dragonfly that discovered it. But what exactly was the mystery, and why is this important now? And what's the solution? So let's start with identifying types of galaxies. And actually this is something that I really love doing in Space Engine, because as soon as you leave the Milky Way galaxy and start looking around, you'll realize how many more galaxies there are in the universe. There are a lot of different types of galaxies, some of them are more visible than others, and some of them are more mysterious than others. It just so happens that because of the advances in the telescope technology, we've started to discover a lot of these so-called ultra-diffuse galaxies, which unfortunately I can't really show you here, mostly because they're very difficult to see, and it will probably take me hours and hours just to find at least one of them. But generally they all sort of look like this, extremely dim and very difficult to see, yet they possess a lot of mass on the inside. And as you can probably imagine, today we believe that most of this mass is essentially dark matter. And in some cases it's been suggested that over 99.9% of the whole mass is dark matter, with only 0.1% being the stars, the visible matter. And although we have discovered a few of these ultra-diffuse galaxies so far, even one relatively close to us actually, there was one specifically discovered about 4 years ago that did actually raise a lot of eyebrows. The galaxy known as Dragonfly 44. And here's why it's called Dragonfly. Simply because it sort of resembles an eye of a dragonfly, and it's essentially a series of commercial cameras all connected together, creating this beautiful and very sensitive telescope. And the main strength of this telescope is in seeing these very difficult to see galaxies. So it's essentially a way for us to kind of search for more of these dark matter dominated galaxies and to possibly try to solve the mysteries related to dark matter. But back to Dragonfly 44. So back in 2016, the scientists realized that something did make sense here. This galaxy seemed to possess approximately the same mass as our own Milky Way galaxy, yet in terms of the number of stars and luminous matter, visible matter, it seemed to possess thousands and thousands of times less, which didn't really make sense because it suggested that the galaxy contained about 10,000 times more dark matter than visible mass. Normally in a galaxy like the Milky Way galaxy, this number is closer to like 10, maybe 100, maximum 300. And even when we find a galaxy with about 300 times more mass in dark matter than visible mass, it already sort of creates a mystery for us. But in this case, the number was 10,000. 10,000 times more mass in dark matter than visible matter. And so for about 4 years now, this was a really big mystery. And so naturally the question here was this some sort of a mistake, or was this galaxy indeed unique and just something that we've never seen before? Naturally, for scientists at least, the more likely answer was that we made a mistake somewhere. We probably miscalculated or didn't really see something we should have been seeing. And even though finding anomalous galaxies and finding mysteries is not really a question here, it's still important to double check your work and to make sure that whatever we found is really there. But before we continue, so let's actually also talk about the differences between the Milky Way and Dragonfly 44, and also how we measure the idea of dark matter in these galaxies. So if this right here is the Milky Way, Dragonfly 44 may resemble something like this. So as you can see, it's kind of difficult to see it, it's very diffuse, there are maybe a few globular clusters here, which are these larger spots you see. And normally a typical globular cluster that contains anywhere from a few thousand to possibly even many hundreds of millions of stars is how we measure different properties of galaxies. So for example, over the years we've discovered that there is a relationship between the total mass of a galaxy and the number of clusters, globular clusters, present in a galaxy. The more clusters, the more mass. And so the original measurements of the galaxy known as Dragonfly 44 suggested that it had about 75 to possibly 80 different globular clusters in it, very similar to the Milky Way galaxy. Yet only about 100 million stars were showing here, and we know that it's at least 1,000 or even more than 1,000 times less than what we have in the Milky Way galaxy. And so normally if we look at a galaxy and we can find the total number of globular clusters, and we then compare this to the total luminosity of the galaxy, and try to estimate how many stars this galaxy contains, we can usually figure out how much dark matter it has. And so these globular clusters are really important for various studies. We also measure the speed of different stars moving in a galaxy, and we also measure, for example, the dispersion velocity of these stars, but today those are usually not as easy to calculate as the number of clusters. And so this is essentially what the new study that you can find in the description below did as well. But they use different telescopes. They used the WM Keck Observatory, the Gemini North Observatory, and also collected the data from the Hubble telescope. And they combined all of this into these composite images to try to investigate how many globular clusters they'll find in these images. And well, it turns out maybe we miscalculated the clusters. It seems that only about 20 clusters were confirmed in this galaxy, suggesting of course that the mysterious dark matter galaxy may not be as massive to begin with. A lot less massive than we originally thought. In this case we have to change it just a little bit to make it look sort of like this. So essentially it contained around 20 different globular clusters, making it dramatically less massive and still possessing a lot of dark matter, but not 10,000 times more, closer to about 300 times more. And I just realized that this made the galaxy even more invisible than before. So we're gonna have to remove the Milky Way galaxy because it's blocking everything. Okay, so what does this make this galaxy then? Well, it makes it a typical ultra-diffuse galaxy. A galaxy that possesses a lot of dark matter, possibly even 300 times more than the typical star matter, but it doesn't make it an anomaly or a strange galaxy that we can't explain. At least according to this recent study. There may be still follow-ups and there might be still recalculations of the total number of these globular clusters in the future, although the way it looks right now, based on all of these observations from different telescopes, the mystery may have been solved. It's a regular ultra-diffuse galaxy and doesn't seem to possess anything too extreme about it. Now, obviously there are still quite a lot of mysteries about these galaxies. We still don't really understand how they're created. We still don't really understand why the mass difference between dark matter and visible matter is so dramatic in these galaxies. And we really don't get why certain clusters, like for example the Coma cluster right here, seem to possess a lot more of these galaxies and a lot more dark matter than certain other clusters closer to us. In other words, there are still quite a lot of mysteries and still a lot of unanswered questions. Just not the question we previously had. It doesn't seem to be an anomaly at all. And also there are some other unanswered questions, even in regards to the globular clusters. For example, we know that there is a relationship between the total mass of a galaxy and the number of clusters, but we don't really understand what the relationship is or how it's developed. We think it's because of the amount of different galactic collisions, which are usually between dwarf galaxies, and a lot of these dwarf galaxies eventually turn into globular clusters, but the answer is not very clear right now. Either way, for now that's kind of all we know about the mysterious Dragonfly 44, and also for now this seems to have solved one mystery in the universe. And today we're going to be discussing yet another mystery / observation coming from the center of our galaxy, the Milky Way. And this time it's a mystery that's been sort of, I guess, mysterious for quite a long time now, for actually close to about 4 decades. The mystery of these unusual filamental structures found pretty much all across the galaxy that we live in, but also in other galaxies as well. With the new updates in regards to this, creating this absolutely mind-blowing image that you see right here, that essentially demonstrates how many of these filaments are in our galaxy, with a new study and some of the new images revealing nearly 1,000 of these unusual strands, with some of them as long as 100 to 150 light years in length, stretching pretty much all over the galaxy, but mostly in the center. With many of them also possessing some really unusual features, many of them being multi-layered or positioned in an extremely orderly manner, with some of them also being part of some other unusual structures, and other ones potentially connected to some other unusual phenomena, such as these unusual radio bubbles that you see right here. And even though the original filaments were discovered back in the early 80s, even today, after 4 decades, the actual explanation and the actual origin of these filaments is still not particularly well understood. Nevertheless, the scientists still have learned some things about them, with a lot of new studies, both describing some of the features observed from these filaments, and also sort of speculating on the potential origins. With I guess the first natural question being, what's inside of these filaments? What are they actually made out of? And the answer here is somewhat surprising. These filaments are most likely made out of extremely fast-moving cosmic rays, and specifically very fast-moving electrons that seem to be moving near the speed of light, with something extremely powerful accelerating these particles to very high velocities, and then as a result producing these very long stretched structures. Like I said, some of them are 150 light years in length, and some of them are also relatively thick. Some of these filaments are at least half a light year in thickness. And so whatever is accelerating these electrons to these velocities has to be super powerful, potentially being some of the most powerful astrophysical events, very likely involving really massive black holes or some really powerful explosions. But because of the way that some of these filaments are structured and the way that they're stacked on top of each other, or because of the way some of them are basically side by side with each other, it's still very difficult to answer if all of these filaments are caused by the same type of an event, or if they're all produced by something slightly different or possibly entirely different. In other words, the mystery is still a mystery. But some of these new studies, especially the ones you can find in the description below, decided to create some of the most detailed observations of these filaments, while also analyzing some of the individual ones, but also studying them as a whole as well, creating the very detailed and somewhat beautiful map you can find in the study in the description below. In the process discovering approximately 10 times more filaments than we originally saw in some of the previous studies. With this very beautiful but somewhat eerie image that was produced using the data from the South African Radio Astronomy Observatory, taking nearly 3 years to produce. And in this case, this is a radio image, or basically image produced in radio frequencies, with the overall frequency being 1.28 GHz, which essentially helped the scientists uncover quite a lot of different phenomena, including some still unexplained phenomena which seem to represent either outbursts from different stars, possible supernova remnants, or some other unusual phenomena such as radio nebula that you see right here. And so by combining the data from some of the most powerful radio telescopes with the ability to finally remove some of the background that was essentially blocking some of these filaments, the scientists were able to discover some really incredible sights we've never seen before. With some of the initial investigations, trying to figure out how the magnetic fields inside these filaments connect to the potential cosmic rays that could be coming from some really powerful sources in order to create these very long, very beautiful features. In other words, the scientists are trying to figure out the exact mechanism responsible for creating these very long filaments. And they are slowly getting to that final answer. For example, some of the initial propositions from many years ago suggested that maybe these filaments are created because of some unusual supernova that create very powerful emissions which then create these particular filaments as a result of some sort of magnetic interaction. But having investigated these filaments and compared them to the supernova observations that do have visible radio emissions as well, the scientists learned that the radio emissions coming from the filaments are actually very different from the ones coming from the supernova, suggesting that their origin is probably not the same. Basically, the supernova are very likely not responsible for this. But approximately 2 years ago, another proposition decided to focus on a slightly different idea. The idea of supermassive black holes that generally are also responsible for producing a lot of cosmic radiation, a lot of cosmic rays around the universe. And this actually kind of connects to the other observation from a very different type of a telescope, from the X-ray telescopes. The Chandra X-ray telescope in the last few years has also been discovering these very similar filaments, but obviously in the X-ray frequencies. Here's actually one of many images produced by the scientists a few years ago. We've discussed this on the channel in one of the previous videos. And right there, the red box is sort of pointing at one of these many filaments, which also seem to possess somewhat similar morphological features. In other words, they also look the same. And so is it possible that their origin is kind of connected? Well, the proposal from a couple of years ago sort of explains how this could form in theory. And in order for this to work, it would just need two things: a relatively powerful black hole emitting very powerful astrophysical jets, creating the so-called cosmic rays, and some sort of a nebula with a lot of gas in it. And so essentially, as all of these cosmic rays from the astrophysical jets start to spread away from the black hole, some of them could end up crossing some sort of a molecular cloud, so basically a nebula. And according to the scientists, with more explanation that you can read about in the description below, the interaction between these very powerful cosmic rays and some sort of a molecular cloud is actually going to produce several different types of very, very light but also very fast moving electrons, with the ones that have higher energy producing X-ray filaments, yet the ones that don't have as much energy producing radio filaments. In essence, explaining that all of these filaments could have been actually the signs of ancient activity of our own supermassive black hole, with some of these jets essentially hitting some of the clouds in the vicinity and producing these effects. And to some extent, this sort of makes sense. Mostly because very similar filaments have already been detected in other galaxies that have been previously active. And some of these galaxies, especially more active ones, seem to have a lot more of these filaments. But at the moment, this is just a preliminary explanation, mostly because even though the scientists have a lot of radio data, with nearly 1,000 of these filaments already detected and explored, at the moment, unfortunately, the X-ray data is really missing. There are just not a lot of X-ray observations, or more specifically, there are not a lot of accurate X-ray observations, because unfortunately there are just not enough X-ray telescopes out there doing all the work. And so until the scientists can start collecting more X-ray observations and find more of these X-ray filaments, and then possibly find a connection between these filaments and the radio filaments, this particular idea is still going to be just a hypothesis and would be somewhat difficult to prove. But nevertheless, it's still the only reasonable explanation we currently have. Okay, I guess it could also be aliens, but it's never aliens, so the only reasonable explanation we currently have. Although it's also possible that at least some of these filaments are maybe connected to some of the other unusual events, such as various radio bubbles discovered in the past. Although even if we can explain their origin, it's still difficult to explain how some of these filaments form in the way they form. For example, some of them seem to have extremely ordered separation between the microfilaments on the inside. In some of these clusters, they seem to be perfectly separated by a distance of about 1 astronomical unit away from one another, which actually sort of resembles what we usually find around the Sun, the so-called solar loops. They also tend to be extremely orderly separated, and all of this is formed by the magnetic lines. And so if these are the magnetic lines of the galaxy, this obviously needs a completely different explanation and would probably require a lot more thinking and a lot more observations and analysis. At the same time, it's not even clear if these filaments change dramatically over time, or even if they move around, mostly because these observations are relatively recent and we haven't really observed any changes yet. And so if there is any motion detected or any additional changes, it might actually be more reasonable to assume that these have a very similar origin story to what we actually detect around the solar surface, magnetic lines. So definitely still a lot of unanswered questions, but I guess still the biggest question is, what created these? How were these made? And along with the other radio mysteries we've discovered in the last few years, such as various radio bubbles, it once again confirms that it's a pretty exciting time for radio astronomy. A lot of new mysteries, a lot of unanswered questions, and a lot of future exciting answers and exciting studies, which means that we'll definitely come back to this and talk about it in some of the future videos. Hello wonderful person, this is Anton, and today we're going to be discussing some other really exciting discoveries coming from the Milky Way galaxy, and actually discoveries that once again nobody kind of expected. Discoveries that you can learn more about in one of the papers in the description below. But also a discovery that's, in some sense, almost like 45 years in the making, because the scientist behind this main paper has been studying these particular phenomena since the early 1980s. And it's essentially directly related to that discovery from the 80s of these unusual floating filaments discovered around the galactic center. If you want to take a trip back in time, here's that original paper by the same scientist published 39 years ago. And so back then, he discovered these unusual filamental formations that were basically only visible in radio light. And quick reminder, if you actually want to ever see what the galaxy looks like in the radio light, check out the map in the description that allows you to see everything in the X-rays, in the gamma rays, in the infrared light, microwave light, and lastly, radio light. And so when looking at the Milky Way in the radio light, something exceptional comes into view pretty quickly. Our galaxy contains a lot of these very beautiful filamental features, very often up to 150 light years in length, vertical in orientation, and most likely following the magnetic lines of the galaxy itself. And the scientists behind this paper discovered over 1,000 of these in the last 4 decades. As a matter of fact, we've discussed many of these discoveries in the past because they do show our galaxy in a very different light, and serve as evidence for magnetic interactions within the galaxy and powerful magnetic lines that most likely influence various star formation and also guide a lot of gas around the galaxy. But these previous discoveries were usually magnetic in nature and almost always vertical, and also mostly served as a direct proof of other observations from similar galaxies, especially with the famous SETI telescope, that directly show us various magnetic fields and magnetic lines visible in many of these galaxies as well. And a lot of these formations always have these filaments and these beautiful line-like formations that seem to follow magnetic structures in each of these galaxies. So basically this was a kind of an indirect proof of the existence of powerful magnetic fields within each of these galaxies, including the Milky Way. It was never really doubted, but this was a direct proof. But this time, the same scientists, using very similar techniques, but obviously using new improved telescopes, discovered something that even they did not expect. Mystery filaments align in a very different way, almost always along the galactic plane as opposed to vertical to it. And interestingly enough, almost always pointing toward the center, which was very different from previous observations from previous filaments. And here's actually what all of this looks like if you were to combine both. And more intriguingly, implying that there seem to be at least 2 different populations of these filamental strings, and possibly with 2 different origins, with this new discovery almost certainly connected to the central black hole Sagittarius A star. Because unlike other filaments, it seems that these ones are aligned in a way that they kind of point in the direction of the central black hole. And though they're also magnetized and are only visible in radio light, they are different in properties as well. So for example, these previous filaments that do seem to be kind of random and don't really have any connection with one another are definitely different from these ones, which all seem to be tied to the center of the galaxy. And even the scientists behind this paper were actually surprised to find them because they expected all of them to be vertical, following the magnetic lines. But unlike these vertical filaments, these new structures are pretty much just short lines. Most of them are only about 5 to 10 light years in length, but there are like hundreds of them, all pointing in the same direction. And although all of them are magnetic in nature, the long structures, the vertical ones, can usually easily accelerate particles to near the speed of light. But these tiny horizontal structures do not. Instead, they seem to emit thermal energy. And more importantly, they're not equally distributed across the galaxy. For some reason, a lot of these newly discovered filaments are mostly arranged on one of the sides of the galactic center, almost as if they're pointing at the radial outflow from the previously active astrophysical jets. The jets that we believe must have been active a few million years ago based on various observations, but that are no longer active now. And more importantly, if you actually trace back when these particular emissions must have started, it seems to have happened approximately 6 million years ago. Which in essence implies that approximately 6 million years ago, something must have formed all of these powerful emissions that eventually produced all of these tiny magnetic lines coming from the center of the galaxy. Which of course implies that our galaxy was probably very active 6 million years ago, emitting very powerful emissions in the process, producing powerful accretion disks and a lot of other electromagnetic effects, and also producing powerful jets that then left behind these unusual filaments. And if this assumption is correct, it actually means that we can now potentially study the accretion disk of the ancient Sagittarius A star. By studying each of these filaments, it might become possible to work out the black hole spin, the size and the power of the accretion disk 6 million years ago, obviously the orientation of the black hole and the accretion disk, and possibly even what exactly caused all of this. And then maybe even work out if this had any effects on planet Earth. It would also be quite important to find the connection between this and the famous Fermi bubbles, although in this case, the Fermi bubbles are believed to have been formed possibly about 2 to 3 million years ago, so there's definitely a bit of a time difference. And though these events might be connected, there's also a possibility that maybe these were two separate events, suggesting that our black hole does this every few million years or so. It basically becomes active, starts spewing out a lot of matter from every direction, creates powerful accretion disks, powerful jets, and leaves behind powerful radio filaments visible from very far away. At least that's one of the first assumptions. The other assumption could be maybe a little bit different. It's also related to a recent study on the so-called Rosetta bubbles, very similar bubbles but only visible in the X-rays that are much bigger, much more powerful, and seem to have been a result of a major star formation in the galactic center and not the activity from the black hole. And so for all we know, maybe these bubbles produced various powerful emissions because of various supernova all happening at once, which then, as they spread away from the center of the galaxy, produced these radio filaments now visible as the formations that the scientists recently discovered. In other words, the actual origin of this is still not really clear. It was definitely a result of something very powerful and something involving a lot of magnetic interaction, but whether it was star formation, black hole emissions, or something entirely different we don't understand just yet, is a question we cannot answer yet either. So today I wanted to start right here, in one of the simulations available in Space Engine. This is the Ring Nebula, one of many different planetary nebulas inside our own galaxy. They were named Planetary Nebula hundreds of years ago because from a distance they do sort of resemble bright spherical objects, sort of similar to planets. But unfortunately the name stuck, even though now we know that these are actually gas clouds produced by various stars very similar to our Sun as they reach the end of their lifetime and become white dwarfs. With the emissions then becoming visible because the white dwarfs are so hot and produce so much ionizing radiation that all of this ends up ionizing the gas and creating effects similar to a typical halogen lamp. And so pretty much all of the stars, approximately 1 to 8 solar masses, are going to form these unusual structures. And that of course includes our Sun. The Sun is most likely going to become one of these as well, billions of years in the future. And so unlike hundreds of years ago, today astronomers understand these objects pretty well. Or so we thought. Hello wonderful person, this is Anton, and today we're going to be discussing this unusual mystery that was discovered approximately a decade ago that has now been officially confirmed, with the mystery in this case not really making sense just yet. But it's a mystery in regards to the alignment of these planetary nebula in the Milky Way galaxy. Because it turns out that, for some reason, the vast majority of them seem to be aligned in a very certain direction. Specifically the nebula that often form unusual bipolar shapes. But what's really unusual here is something that becomes apparent if you look at many of them at the same time. For some reason, many of them seem to be directly aligned on some imaginary axis that actually does not make sense right now. And since here we kind of expect all of these objects to have alignment in random directions, why exactly they seem to be pointed in the same way is of course that mystery we're going to be discussing today. But first, a very important clarification. This does not affect all planetary nebula. So for example, the one I showed you previously, the Ring Nebula, does not actually have any bipolar shapes, and so it's not going to be affected by this at all. Here's actually the real picture from the Hubble telescope, and so even though there is a bit of a stretch in two directions, the actual shape is still more or less spherical. But other examples, like the Cat's Eye Nebula, definitely show more sidedness with very pronounced directions. And so today the assumption is that any star that's singular is most likely going to form some kind of a spherical object, whereas a binary system is probably going to end up with something a little bit more stretched and something containing what's known as bipolarity, kind of resembling two separate jets aimed at opposite directions. But here it's also important to remember that all of this happens really quickly. These objects very often last for just a few thousand years, slowly disappearing as the white dwarf cools down and as the gas disperses. And so after approximately 10 to 50,000 years, pretty much most of this would be invisible. Nevertheless, because there are so many stars similar to our Sun that have reached the end of their lifetime, our galaxy will constantly be getting more and more of these objects as many stars evolve and reach the end of their lifetime. But back in 2011, by studying new images from the Hubble telescope, something unusual was discovered about these bipolar nebula. Quite a lot of them had their long axes aligned with the galactic plane, basically entirely parallel to it. And so if this is the galactic plane right here, almost every single one of these bipolar nebula was almost parallel to it. This was originally discovered back in 2011 by Brian Rees and created a pretty big mystery. But because this was not an official study and was actually his PhD thesis, and also because this was a pretty big assumption, it took years and years of analysis and additional pictures to finally definitively confirm that this is indeed what's happening here, with what's known as 5 sigma confirmation. Basically this is very likely to be true, but only affecting certain types of planetary nebula, which is why it was important to find out what possible mechanisms could be responsible for all of this. But the thing is, even today, the actual evolution of shapes inside these nebula is still not very well understood. There's actually a video in the description that goes a little bit more through this, but in a nutshell, it's still not super clear how some of these nebula get exact shapes. What is clear though, is the effect from having a partner star. What is clear is that partner stars very often produce very specific effects, with the main discovery being in regards to the types of binaries that seem to form these alignments. It seems to only happen to stars with very tight orbits. In other words, if you have a star orbiting another star relatively close to one another, as one of them goes through its nebula stage, it has a very high chance of developing these unusual structures. And not just bipolar structures, but bipolar structures with a very certain alignment. Whereas binary stars with much larger separation, or singular stars, do not produce similar effects. They will produce bipolar nebula, but they're not going to produce alignment with the galactic plane. At least that's the main conclusion from the paper so far. But the question is, why? What's actually happening here, and why are certain nebula aligned, others not? In short, the current explanation involves magnetic fields. But to be more specific, it's the effects from the magnetic fields when the stars are still forming. We've discussed magnetic fields in galaxies in some of the previous videos, you can find some in the description below, but in a nutshell, we know galaxies have magnetic fields. some galaxies seem to have much stronger fields than others. Whereas for the Milky Way galaxy, today the fields are not very strong, but they could have been strong billions of years ago, especially when the galaxy was more active. And though these fields generally do not affect stars, they do affect gas that circulates in a galaxy and that then creates new stars. And so in order to have such an unusually neat alignment, all of these binary stars would have to be created pointed in a very similar way. Basically, billions of years ago, something would have to align all of this gas in a very certain way in order to then form stars pointed in the same direction, with that something very likely being magnetic lines of the galaxy. The lines that today resemble something like this, and the lines that are still guiding all of this gas, making it orbit around the galaxy in a very certain way. Here's actually what all of this would look like if we could see it, coming from a slightly different galaxy with more powerful magnetic fields. And so based on these observations from other galaxies, we can actually assume that at some point the Milky Way galaxy very likely had these powerful magnetic fields as well. And they would have been powerful enough to align the gas to then form stars in a very certain way, which in essence would lock all of this gas before it even starts forming stars into a very certain motion following a very certain path, with stars orbiting very close to one another, almost directly aligned along those lines. Whereas singular stars, or stars on a much farther orbit, not really affected by this as much, with these effects particularly visible extremely close to the galactic bulge in the center of the galaxy, where we do expect much stronger lines and of course much stronger magnetic effects. And this also implies one thing: some stars, especially binary stars, might actually have a slightly different formation history, which results in a very different alignment. In other words, they might have been created in a different environment from slightly different molecular gas or slightly different star nurseries. And because these nebula also enrich Milky Way galaxy with a lot of different elements, it of course all relates to the idea of evolution of galaxies. It might actually help us solve the mysteries of Milky Way evolution. But more importantly, by studying the direction of these nebula, we can also now start studying the magnetic lines in the galactic bulge, which at some point might help scientists map the magnetic environment right at the center of the galaxy. But that's of course if the assumption is correct, if this is indeed caused by magnetic lines, and if this is all a result of formation of tight binaries in the early galaxy. There might be some explanations in the future, but at least for now, it's the only one we have. Right behind me is a very peculiar object. An object that's located right here in the Milky Way, and that even today is quite mysterious, with the main reason for the mystery being something that happened here nearly 200 years ago, back in mid-1800s. It's known as the Great Eruption, and it was essentially an appearance of an extremely bright star that suddenly became the second brightest star in the night skies. And intriguingly, it maintained its brightness for nearly 20 years, finally fading in 1856. And though back then nobody actually knew what's happening here, modern observations, including Hubble Space Telescope, essentially reveal what's now known as the Beautiful Homunculus Nebula. Enormous beautiful nebula produced almost 200 years ago that even today still is very difficult to explain. The only thing we know about it is that it was very likely a result of some kind of a major disruption of the central star, and it's also most likely what we often refer to as the supernova imposter, produced by the central star Eta Carina when it was initially approximately 150 to maybe 250 solar masses, but lost a huge amount of mass without going fully supernova, but still producing very bright, very large emissions, making it appear as a supernova for many years. And today, this concept is sometimes referred to as the eternal supernova, one of the bigger mysteries in modern astronomy. And well, hello wonderful person, this is Anton, and in this video we're going to discuss some of the recent analysis, recent simulations, and recent conclusions when it comes to a very peculiar, very exotic type of supernova that might have finally been explained, with this potentially being the best example that happened right here in the Milky Way. And generally these supernova are referred to as PPI supernova, pulsational pair instability supernova,
which only occur in stars of a very specific mass. For example, the most common supernova, Type 2 supernova, happens when a star of a certain mass collapses, producing a neutron star or a black hole as the final leftover. These only happen in stars that are at least 8 solar masses, but potentially not more than 80 solar masses, because at that point, something else starts to happen inside stars. We also have Type 1 supernova, resulting from the explosion of a white dwarf, which are also pretty common, but do not necessarily involve large massive stars. Type 1 and Type 2 supernova are the most common types we see across the universe. But occasionally stars can get pretty massive, especially in certain locations in various molecular clouds. This was of course one such star, but generally quite a lot of these stars are located in the Carina Nebula, and even more of these stars are found in the nearby Tarantula Nebula inside Large Magellanic Cloud. And for stars over approximately 80 to 90 solar masses, something else starts happening inside of them. They essentially start acquiring a lot of instability based on effects from both Einsteinian theories and theories involving the light pressure that prevents stars from collapsing. So for example, if you were to find a very large massive star, and if you were to look inside of it, you would discover that in very large hot stars, the pressure from gamma rays, which are produced inside very hot objects, keeps the upper layers of the star supported from gravitational collapse. And the hotter the inside, the more gamma rays are produced, the more support they provide. But with very powerful photons, and especially gamma rays, something else starts happening once they acquire certain energies. At some point, they start interacting with a lot of other stuff nearby, and actually have a chance to suddenly convert into physical mass. Basically converting gamma rays into electron-positron pairs, which though does increase the mass of the star, also reduces the external pressure. Or in other words, some of these gamma rays can no longer support the star from collapsing. And the hotter the star gets, the more pressure it gets, the more of these gamma rays are going to be converted to physical mass, electrons and positrons, which in theory makes the star just a little bit smaller, increases the overall pressure inside, and increases the temperature even more. And though some of the electrons and positrons can then convert back into gamma rays, at some point it can actually reach a kind of a critical mass, where a lot more gamma rays are removed from the inside, causing a kind of instability inside the star. And in stars of approximately 130 to 250 solar masses, we call this pair instability, which results in a pair instability supernova. A type of a supernova that technically destroys the whole star in a very short period of time, as it continuously collapses more and more, releasing massive amounts of energy in the process. And stars over 150 solar masses will almost always produce these types of supernova. Yet stars that are maybe a little bit less massive can produce something a little bit more exotic. Because it turns out that if a star is only about 100 solar masses, to maybe maximum 130, it might not actually have enough pressure on the inside to completely finalize this process, exploding the star to the end. And instead, what was discovered over many years is that it seems to actually create what scientists sometimes refer to as eternally luminous supernova or pulsating supernova, which repeat many times over many years. And Eta Carina, or the Homunculus Nebula, is believed to be one of such examples. But because in this case the final star is still there at the end, it's sometimes also referred to as the imposter supernova. A supernova that happens for many years but does not destroy the star at the end. Or at least it doesn't at first. In many cases, it does seem to result in a supernova at the end, potentially producing a black hole. Here though, after almost 200 years, it seems to be still around. Which of course makes this a pretty big mystery. But a mystery that we might have just solved through this relatively recent study. So first of all, in the last few decades, at least a handful of these very mysterious exotic supernova have been discovered in other galaxies. They're sometimes referred to as what's known as Type 5 supernova, and here's maybe one example that happened in 2010. Although SN 1000+0216 that was discovered in 2006 is a bit more well known because it was so bright that at that point it was one of the farthest supernova ever detected, directly seen in a galaxy billions of light years away. And because of the sheer brightness and the length of the supernova, it was difficult to explain this as either Type 1 or Type 2. It was an exotic supernova
almost for sure. Another similar event was actually detected by the iconic Fritz Zwicky back in 1961. Once again, a very similar explosion that was way too bright and lasted for a very long time. But a much more intriguing event is the event you see right here. A strange supernova that was continuously erupting for at least 3 years and had even previously erupted back in 1954, finally disappearing around 2017. And so in many of these cases, the actual observations are very similar. They almost always at first appear as a typical supernova that's not super bright, with the brightness diminishing over time, but then repeating many times, very often lasting for many months or even years. With a regular supernova, you're unlikely to see anything after just a few months. The peak brightness normally occurs within just a couple of weeks. Here though, it's repeated many times, with many additional explosions sometimes being even brighter than the first one. And depending on the original star, they seem to either appear as Type 2 or sometimes Type 1 supernova, but in some cases being even brighter than either one of those, maintaining this brightness much longer than they should. To solve the mystery, researchers behind the paper in the description performed one of the most complex supercomputer simulations, helping them visualize exactly what happens inside these stars. But unlike previous simulations, which were often either 1 or 2-dimensional, and unfortunately did not provide enough details, this supercomputer simulation that used approximately 5 million computing hours used 3-dimensional hydrodynamics to visualize a lot of different kinds of turbulence that was previously invisible in 1 or 2-dimensional simulations, in the process discovering that a lot of this turbulence plays a very crucial role, with the overall conclusion being that, well, it does seem to act as a kind of a fountain-like eruption, with several smaller supernovae repeating over and over, as a lot of different types of gamma rays inside the core trigger pulsations in various layers, leading to several violent contractions, which then lead to minor explosions. And it looks like each of these contractions is basically a mini supernova, sometimes actually a really bright one. And sometimes, just like with the Homunculus Nebula, various eruptions tend to interact with material from different previous eruptions, producing additional brightness and additional bright emissions, making the overall object appear extremely bright in a lot of different frequencies of light. And that's precisely what happened with the Eta Carina and what essentially produced the Homunculus Nebula, several pulsating explosions that happened over many years, resulting in the object that became the second brightest star in the night skies. And when a lot of material from previous eruptions interacts and collides together, it usually adds up to 30% of various energetic emissions, making this appear extremely bright, even if nothing is happening inside the star anymore. Which to some extent explains some of these superluminous supernova we've seen so many times in the past. But at some point, these stars lose so much mass that they actually become less than 100 solar masses in mass, and this is when the pressure inside is no longer enough to convert gamma rays into electron-positron pairs, which basically kind of ends the whole process and leads to one of two possible results. Either the star explodes, finalizing the whole process and leaving behind a black hole, or it becomes what you see right here, a really massive, really bright star that's still kind of unstable, still has not exploded, but will explode in the future. We don't really know when, but sometimes in the future. And so within just a few years, these stars tend to lose anywhere from 10 to maybe 30 solar masses in material, which of course creates these beautiful nebula, and also adds a lot of material to the rest of the galaxy, helping the galaxies evolve in the process. With this whole process also helping us understand how many different massive stars seem to evolve and seem to change with time. So definitely an intriguing analysis and an intriguing discovery. But exactly what happens to the Homunculus Nebula and Eta Carina at the moment is still not really clear. Nobody is actually still certain why the star did not explode like so many other pulsating pair instability supernova. For some reason, this star decided to take a break. And so it's definitely still going to explode in the future, but at the moment nobody knows when. In the last few decades, scientists have found so many different ways to study the Sun, be it through observations with various telescopes or through the study of various sunquakes, the science known as helioseismology, we've actually learned so much about this beautiful object, the object worshipped by various cultures for many millennia. And I mean, for obvious reasons. It provides life to our planet. But even though we understand so much about the Sun today, we still don't understand pretty much just as much. There are still so many mysteries that we cannot answer, and even mysteries in regards to something that actually happened not so long ago. And so, hello wonderful person, this is Anton. Today we're going to discuss the Sun once again, but specifically focus on a relatively recent study that actually discovered something else about a very unusual period that the Sun went through that we today refer to as the Maunder Minimum. Something that started in 1645 and finished in 1715 and basically represents an unusual long sunspot minimum when the Sun was surprisingly extremely inactive. It essentially contained practically no sunspots at all, thus suggesting a period of extremely low activity. And that's of course because we know that today, solar activity directly correlates with the amount of sunspots we detect on the surface. Every time we see more sunspots, we also tend to detect a lot more solar emissions and a lot more different types of solar storms that are generally formed from various regions around various sunspots. And so leading up to what's known as the solar maximum, we normally detect a large amount of sunspots on the surface of the Sun. Or at least that's the pattern from the last few hundreds of years. But the English astronomer Edward Maunder, along with other astronomers, discovered that years prior, a lot of the observations here were actually very different from anything we're seeing now. For example, between 1672 and 1699, only 50 sunspots were detected in total. Some years there were basically none, and some years there were just one or two. And that's in contrast to approximately 50,000 sunspots that we would be detecting in modern times in the same 30-year period. And naturally the first explanation here is that, okay, maybe nobody was looking, nobody was counting, or they were counting but they were doing something wrong. But turned out that that's not the case. As a matter of fact, because of this guy, that's Giovanni Cassini. The same Cassini we have so many things named after. He was doing accurate observations before that, and he was doing them during the Maunder period as well. He sort of reported the same. Almost no sunspots, using some of the most advanced equipment at the time at the Paris Observatory. And so whatever was happening here was definitely happening with the Sun. Intriguingly, during this time, during this grand solar minimum, something else unusual happened on the planet. It's known as the Little Ice Age and essentially represents a slight cooling on the planet that might have happened during this time as well. And though this was an intriguing discovery at first, eventually studies determined that this climatic cooling was primarily caused by volcanoes. And though the solar minimum might have played a role, it was not a very big role. And I guess even more importantly, studies focusing on these minima discovered that this is far from the only one out there. For some reason, the Sun seems to like doing this once in a while. At least 18 different periods were discovered in just the last 8,000 years by studying various samples from various ice cores that usually contain data from various isotopes of beryllium and carbon, allowing us to link solar activity to production of isotopes in the atmosphere. And so it looks like our Sun actually spends at least a quarter of the time during these unusual inactive periods or these unusual minima. Or at least these were some of the initial implications from some of the studies. But it looks like now we're in some kind of a modern maximum period with much higher activity from the Sun, something that also has very little explanation. Okay, quick and important side note that I'm sure is going to be mentioned in the comments. Even though there is a correlation between modern maximum and the increase in temperature on planet Earth, multiple studies established there's actually a kind of a reverse correlation between recent solar activity and the increases in temperature. In other words, no, the solar activity is not causing global warming, just so that we're kind of clear on this. However, trying to figure out exactly what's happening to the Sun, and of course where all of this is headed, is still really important. And so that's why so many scientists wanted to focus on these minima in order to basically then understand the maxima. And when it comes to Maunder minima, and specifically the data about these unusual events, a really intriguing study came out back in 2021 that essentially used various observations of aurora described by various ancient Korean astronomers and then directly linking all of this to observations from other astronomers and to solar activity. And the thing is, back in the days, Korean kings demanded a very accurate daily report of various astronomical events in order to then use that to guide their decisions in state affairs, royal businesses, or even in personal life. So basically, by observing the stars, they wanted to figure out what to do next with their life. And so they had extremely accurate records of astronomical events, starting with 918 AD all the way to 1910. Basically, a millennium of observations. But for this particular study, scientists were mostly interested in aurora. And though it's kind of almost impossible to see aurora in Korea, sometimes it is possible. Mostly because of this unusual magnetic anomaly known as West Pacific Anomaly, an area extremely close to Korea that produces a slightly thinner magnetic field, thus resulting in slightly more magnetic activity and magnetic storms. Or in other words, this area sometimes produces aurora. At least one type of aurora that seems to be common here, a red aurora. Aurora that usually happen really high up in the atmosphere, 300 to 400 kilometers in altitude, where a very low concentration of oxygen results in oscillating atoms that then end up producing high frequency of light. And in this case, they basically then form red colors, visible very high up because they're also extremely far. Compared to other aurora, red aurora are kind of rare and are usually associated with much higher solar activity. And so sometimes they're visible here as well, and have been mentioned many times in various astronomical sections of daily chronicles by the royal astronomers. Here they actually call them red vapors, or vapors like the firelight, which would be very difficult to explain in any other way. And so by analyzing these chronicles, researchers behind the recent study were able to then calculate how often these aurora were also seen during the Maunder minimum, with the resulting observations suggesting that it looks like the solar cycle might have been actually different back then. Even though the modern observations suggest that these aurora happen every 11 years, because the solar cycle today is 11 years long, the observational records of these aurora suggest that the cycles back then were only 8 years long, at least 8 years long on average, potentially suggesting that not only is the Sun able to increase and decrease its activity and enter various minima and maxima, it also seems to be able to change the length of its cycle as well, or at least enter certain periods, potentially anomalous periods, when the activity cycle decreases in time as well. But obviously why this happened is currently unknown. With the other discoveries also suggesting that none of the aurora around this time were in any way different or more chaotic, because the observations of those aurora present them in a more casual, more typical way. And so during the Maunder minimum, aurora have been observed with a somewhat regular appearance. But during the different minimum, known as Dalton minimum, that happened during 1800s, even aurora changed as well. And I guess here the implication is that maybe the Sun seems to do different things at different times, and we still have so much to learn about it. But specifically, we need to learn more about what it currently is doing, because even though the solar activity was slightly decreasing over time in the last few years, it then suddenly entered an extremely active cycle that we have right now, much more active than the cycles scientists were predicting, and much more active than the previous two cycles. In other words, just like with so many other things when it comes to astronomy, and of course the Sun, this field is still in its infancy and we still have so much to learn. But in this case, this particular study, or these studies, are super important, because whatever is happening to the Sun or whatever happens in the future is going to directly affect us in so many different ways, technologically, in terms of our lifestyle, and for all we know, maybe also through some other changes to the planet we live on. And so trying to figure out what's happening here and learning more about the Sun is why all of this is kind of important. Hello wonderful person, this is Anton, and today we're going to be discussing a discovery of a very strange object. Basically, the hottest object that's not a star. An object whose temperature is so extreme that it's literally hotter than our own Sun. But an object that's not a star at all, and it's actually kind of closer to being a planet. And so in this case, let's discuss a little bit more about what exactly the scientists have recently discovered, and talk about how this object was formed, and what exactly this means for astronomy in general. But first, so what exactly is this and where is it located? It's approximately 1400 light years away from planet Earth, and it's actually a somewhat typical binary system. A system containing two objects orbiting around one another. But unlike a typical binary system with two stars dancing around a central point, here the central star is a white dwarf. The end result of stars like our Sun, that after billions of years of existence expel their outer shell, leaving behind nothing but the star's core. And that core is the white dwarf that occasionally has different objects in its orbit. And in this case, this object does seem to have something in its orbit, something that's almost a star in terms of mass. An object with a mass of 75 to possibly 88 masses of Jupiter, but also an object that orbits very close to the white dwarf. Now normally this would qualify as a brown dwarf, but at these masses it's actually right at the limit where it should technically become a red dwarf or basically a star. Yet it doesn't seem to be one, but it's really the other properties, specifically temperature, that seem to make no sense. Although here, let's briefly talk about the, previous record holder. So, a few years ago, by studying various exoplanets out there, and by looking at their passage in front of various stars, the scientists identified an extreme star system known as Kelt 9. Here the planet, Kelt 9b, was orbiting so close to the star that it basically became the hottest planet ever discovered. The planet, whose temperature on the surface was over 4000 degrees Celsius, or approximately 4600 Kelvin. But all of this was a result of a close orbit to the star, and the star itself being relatively hot as well. But for nearly 8 years now, this was the record holder, and it definitely taught the scientists so much about these extreme objects. For example, because of these extreme temperatures, quite a lot of material here basically dissociates, turning into atomic elements, with a lot of these chemical elements eventually going through so many different changes that we didn't know existed until observations from a few years ago. You can find one of the older videos somewhere in the description that goes through these recent discoveries. But with a temperature of 4600 Kelvin, the scientists for many years believed that this is maybe as hot as it gets when it comes to extreme planets and extreme atmospheres. Anything hotter than that would be almost impossible. But not everyone believed so, and some scientists assumed that we can maybe find something even hotter around objects that are a little bit more extreme and a little bit more unusual. Specifically very young white dwarfs with extreme temperatures on their surface. Now a typical white dwarf actually starts really hot after it becomes a white dwarf. Here we're talking about tens of thousands of degrees Kelvin. And over time they do lose quite a lot of this temperature because there's basically nothing providing any more energy within them, but that cooling process takes billions of years, and it will actually take trillions of years for these objects to cool down enough to barely produce any light. And so in order to study even more extreme environments, the scientists behind the study wanted to find something similar around a typical white dwarf. They basically wanted to find various gas giants, or maybe even brown dwarfs, inside some kind of a white dwarf system. And because white dwarfs are also much smaller than typical blue supergiants, it would be much easier to see any companion, especially the one that's heated, orbiting around these objects. And the point here was to find some kind of a brown dwarf, or some kind of a Jupiter-like object, that would be close enough to the white dwarf to be dramatically heated by its emissions. Although normally, when we talk about brown dwarfs, we basically refer to objects that are at least 13 masses of Jupiter. Objects that acquire just enough mass to no longer be planets and to start possessing new properties, including certain types of fusion inside their core, but not hydrogen fusion, so basically they're not stars yet. They do fuse deuterium and sometimes lithium, so they can actually produce their own heat and thus increase in temperature with mass. Although some of the most extreme brown dwarfs discovered so far have actually never been above 18 Jupiter masses. At 80 Jupiter masses, the average temperature on the surface would be about 2500 Kelvin. So not as hot as a typical red dwarf, but much hotter than anything else. One of the videos in the description talks about some of the more unusual discoveries in regards to brown dwarfs in the last few years. But what happens if you put a very hot brown dwarf next to an extremely hot white dwarf? And that was basically the question the scientists behind this study were trying to answer. And turns out that what happens is an irradiated Jupiter analog hotter than the Sun. An object so extreme that its temperature is thousands of degrees hotter than most stars in the entire galaxy. And that's of course something that nobody expected. And so even though this particular white dwarf is not actually that extreme, it's only about 40% the solar mass, and its temperature is around 36,000 Kelvin, there are definitely hotter white dwarfs out there. Because of the proximity to the brown dwarf, with the orbit only taking about 2.5 hours, the residual heat coming from the white dwarf creates so much energy that it basically turns this unusual brown dwarf into something that's most likely blue or white in color, with the average temperature on the surface exceeding 8000 Kelvin, at least on the so-called day side. Because this object is most likely tidally locked to the white dwarf, it seems to always point with the same surface toward the white dwarf,
and thus has one side that's much hotter than the other side. Just as a reminder, the temperature on the Sun is about 5700 Kelvin. And so here the temperature is so hot that most of the atmospheric molecules very likely don't just become atoms, they become ions and produce other unexpected effects that we've never really observed or even imagined happening anywhere out there. And so here, by observing this particular star system using European Southern Observatory's Very Large Telescope, and specifically the instrument specializing in ultraviolet radiation, the scientists were able to observe huge amounts of hydrogen that seemed to be coming off from the day side of this particular brown dwarf, but the temperatures observed here were anywhere from 7000 to even 9800 Kelvin. But even the night side here is relatively hot. Not as hot as the day side, but it seemed to be about 1300 to maybe 3000 Kelvin, or about 6000 Kelvin lower. And so here we had this very strange object that we've never seen before, whose temperature differed by about 6000 Kelvin one side to the other, with the day side being so extreme that it's actually brighter than a lot of A-type stars. But all of this was very likely the result of extreme heat coming from the white dwarf and because of the overall proximity. At these distances, any object would actually have temperatures of over 5000 Kelvin because of the emissions from this white dwarf, and specifically the ultraviolet emissions coming from its surface. It actually seems to receive thousands of times more ultraviolet radiation than the previous record holder, Celt 9b, which definitely makes this brown dwarf the strangest brown dwarf ever. It's obviously not even a brown dwarf anymore, and instead might represent a completely new object. Not only is its color no longer brown but more likely blue or even white, even its mass is way above what we expect from a typical brown dwarf, so it's not even clear what sort of fusion it has on the inside or if it technically can qualify as a red dwarf. But in this case, because it's so close to the white dwarf, it's also stretched quite a lot, and so in reality it's probably unlikely to have any kind of fusion because of various disturbances from its smaller but more massive partner. And so in this case, this is just a really extreme example of a somewhat strange, unexplainable object. I mean, we actually understand why it's so hot and what's happening here, we just don't really have a good name for it. But because the scientists now know exactly what to look for, chances are they might find something that's even more hot if they can find an even younger white dwarf with yet another brown dwarf orbiting very, very close. Although in this case, I guess the bigger question is, how exactly did the star system form? Or to be more exact, how exactly did this brown dwarf make it so close to the white dwarf, assuming current orbit? Since this used to be a much larger star, it should have actually swallowed or destroyed any object in the vicinity of its orbit. Moreover, it will be interesting to find out if the white dwarf is also stealing some of the mass from its partner and might one day produce what's known as a nova, a thermonuclear explosion which is usually a result of huge amounts of hydrogen and helium depositing on the surface of a white dwarf. It's not going to go supernova because it just doesn't have enough mass, but other types of explosion would be possible here. And if that does happen, it might even disrupt the brown dwarf, potentially creating something else in the process. But these are not the questions we can answer just yet because, once again, this is a relatively recent discovery, and this is the first time such object was discovered anywhere. So there's a star behind me, and it's a star that most of us are actually quite familiar with. It's Polaris, the North Star. The star that many of us, when we're younger, are taught to use as a kind of a guide because it always points directly at the north, no matter where you locate it on planet Earth. Which becomes really apparent if you take a time lapse staring at the star for many hours. It's right there, right in the middle. And since it's also one of the brightest stars in the constellation of Ursa Minor, or the Little Bear constellation, for many centuries and possibly millennia, it's basically been used in navigation across various cultures. But even though we call it the North Star, in reality this is actually a triple star system. A star containing three separate objects with very intriguing parameters and also representing a type of a star system that's extremely important for modern cosmology. A star known as the Cepheid variable, a typical pulsating star whose pulsations are directly dependent on its brightness, and also on its total mass. Basically, this is one of the best ways we can measure distances to quite a lot of different galaxies out there, making this one of the most important types of stars. This is, by the way, the pulsation of Polaris as it changes its brightness just like a typical Cepheid variable.
But extremely recently, scientists discovered something nobody expected. There seem to be unusual changes in its fluctuations, and it seems to have been doing it for at least 200 years. And so, hello wonderful person, this is Anton. And so today we're going to discuss this relatively recent paper and some of the recent observations in regards to unusual pulsations of Polaris and how this might affect our understanding of the entire universe as well. But I guess let's start with the basics. So what type of a star or what type of stars are these? And what exactly is happening here? The main star here is what's known as Polaris AA. It's essentially a yellow supergiant or an F-type star that's around 5.5 solar masses. And that's the star that's producing these pulsating observations. It also has a very close F6 partner known as Polaris AB with a mass of just a little bit larger than the Sun. Here's roughly what the orbit of these two stars looks like. And the orbit here is relatively slow. It takes almost 30 years, with the eccentricity of about 0.63. But as a much larger distance, they have another partner. The partner known as Polaris B, a star that's also very similar to our Sun, approximately 1.4 solar masses, but that orbits much farther away, approximately 2400 astronomical units, with the orbital period being very close to about 40,000 years. And in terms of the distance to Polaris, it's approximately 448 light-years away from planet Earth, so definitely relatively far. But because F-type stars are usually relatively bright, and because there are 3 of them in the system, it makes this one of the brightest stars in the night skies in this particular constellation. But as I mentioned before, the main star is also a classic Cepheid variable, a very important type of a star that pulsates with extreme regularity, forming luminosity curves that look something like this. In this case, a period is about 4 days long. So every 4 days it goes between super bright, super dark, super bright, super dark, with all of this variation being a result of changing diameter and the temperature of the star. And what's interesting about Cepheid variables or these pulsating stars is that this unusual pulsation is directly connected to their total brightness. And because of this, by looking at various Cepheid variables really far away, you can actually usually tell exactly how far away they are, because you can find out their total luminosity by looking at the stars like Polaris right here. Which is exactly what was recently done by looking at approximately 300 such stars using the James Webb Space Telescope in order to try to confirm the distances to various distant galaxies. Or to be more exact, in order to actually see if what's known as the Hubble tension, the strange observations in regards to the expansion of the universe, would still be a problem if this data is reanalyzed with James Webb Space Telescope. And well, spoiler alert, the data from the James Webb determined that Hubble tension is really there. The universe seems to be expanding at different rates depending on where exactly you look. You can learn a little bit more about this unusual concept in one of the videos in the description. But the thing is, the recent observations from Polaris do make things a little bit more complicated. Once again, this is a classic Cepheid variable, and turns out that it's actually changed its pulsations over time, something that right now is somewhat difficult to explain. But first of all, because this is such a well-known star, astronomers have actually been collecting data about the star for nearly 200 years. And the nature of Polaris as a pulsating star was originally established back in 1911. But what's interesting is that most of the observations from the 20th century seem to suggest that the period has been slowly increasing over time, but the total amplitude of pulsations has been declining, with the data suggesting that it increased by about 4.5 seconds every single year, except for the years of 1963 to 1965, where it seems to have reversed. Nobody knows why. But basically, for the past 100-something years, the pulsations have been increasing, even though the actual increase was not super dramatic. And though it's obviously not certain why this is happening, the only explanation we do have is just in regards to the system being a triple star system. Maybe one of the stars is influencing the main star and is causing it to pulsate at slightly different periods with a lot less amplitude. Although honestly, this is just a guess, there is really no good explanation just yet. But what's even more intriguing are the recent observations from just the last few years. Even though for 150 years the period has been getting longer, something started to change sometime around 2010. In essence, decreasing the pulsation period instead of increasing it. And what's even stranger that back in the 1990s, the overall amplitude of change became so small that it even appeared that the pulsations might stop completely. And the most recent observations suggest that the amplitude is no longer increasing and seems to be coming down. In this case, all of this was measured by using what's known as radial velocity, by focusing on the minute changes in redshift and blueshift, which indicates the total velocity of the star. And in this case, they had quite a lot of these measurements, almost 4,000, going back approximately 60 years. And so right now it's not clear what's happening here, but it's most likely due to the orbital changes. For example, the closest star that orbits every 29 years is most likely disturbing some of the upper layers of the main star, changing the pulsations just a little bit. And because the orbit here is relatively eccentric, we actually do expect large changes, especially when the stars approach one another much closer. This happens every 29 years. And so the influence of partner stars is the only explanation we currently have for what could be happening here, and why this classical Cepheid variable is changing its pulsating period. Interestingly, in this case, it also became possible to create a much more accurate orbit of the entire star system. But because of this discovery, it of course also presents a problem. As I mentioned before, Cepheid variables are often used to determine exact distances. Now, if other Cepheid variables are also affected by their partner stars, and even to a much larger extent, it's something that we have to be aware of, because it could be actually skewing the overall distance measurements when it comes to various distant galaxies. In other words, this is a phenomenon that should be studied a little bit more in order to understand exactly what's happening here, and if maybe this is the reason why there is a certain issue when it comes to measuring distances and when it comes to the expansion of the universe, so-called Hubble tension. So definitely some really exciting discoveries from the iconic star Polaris. Hello wonderful person, this is Anton, and today we're going to be talking about the so-called Exotica Catalogue that was released by the SETI Institute to help scientists studying various different anomalies and various different phenomena to kind of get an idea of what we already know about the universe around us. It's an extremely important catalog, but in this video I wanted to focus on 11 different anomalies identified in the catalog that currently make absolutely no sense to us. In other words, let's talk about these scientific anomalies identified by SETI that are most likely not aliens, but I guess you never know. Now, the catalog itself includes about 700 different entries, and all of them are extremely well researched. But I wanted to focus on the outliers and, as they refer to them, anomalies. This paper identifies 5 classes of different anomalies, with the first 3 being just physical phenomena that we can kind of explain but with some uncertainties. But the class 4 and class 5 anomalies definitely need an extra investigation because they're kind of weird. There's a lot of things in there that don't make sense. And so let's talk about some of the bigger ones here. The first one I wanted to mention in this video is something we haven't really talked about much, and also something that hasn't really been discussed much in scientific papers, but it's known as the impossible triple star. In other words, it's a triple star system, many of which we've already discovered in the past, but in this case, when the scientists were looking at this triple star system, and specifically here it was the Kepler telescope looking at the dips of the star as it passes around its partner, the scientists, after 4 years, realized that these dips made absolutely no sense. No triple system should be producing these dips, and no orbital configuration could explain what the scientists were observing. They ran many different simulations and none of it made sense. So they thought that maybe there are 4 stars here, maybe we're just not seeing one of the stars, and one of the simulations did show some similarity to a very complex 4-body system, but even that was not really truly explaining what's happening here, and so even today the scientists have no idea what's going on in this particular star system. The observations of dips around these stars simply make no sense, and something else is going on here, but we just have no idea what it is, either physically or even astronomically. At the end of the paper, the scientists even state, "We urge further observations to uncover the true nature of this remarkable object." Because right now, there is really no explanation. Now that's number one. Number two anomaly comes closer from home, and it's something we've actually discussed previously on the channel. It's the detections of extremely powerful neutrinos coming from inside our planet. A few years ago, the scientists discovered that some of the really powerful neutrinos were actually coming from inside of the ice, and it made absolutely no sense because normally these types of neutrinos are only formed in some really extremely powerful events like, for example, supernova or distant black holes. But because it was coming from inside our planet and not from the top where it should have been coming from, there's been a lot of speculation trying to discover what's going on. Some of the articles online even suggested that this was discovery of the parallel universe where time runs backward, but I've previously mentioned in one of the videos that this is not what the scientists think at all. Today there's really no good explanation to what we might have been seeing, but some of the explanations include maybe something happening inside the ice under Antarctica, or maybe some kind of a known reflective feature of ice that we've never investigated before. There could be other explanations, but it really wouldn't be an anomaly if we knew what's happening here. Another unusual event was also detected in Antarctica, but this time it was neutrinos coming from exactly the same point in the sky within about 100 seconds of each other. This was known as the neutrino multiplet event, and it's an event that we don't really expect to happen. A neutrino coming from exactly the same point of the sky should happen every 14 years or so. But this time we had 3 neutrinos coming from exactly the same point within about 100 seconds. And the most mysterious part is that there was nothing in that part of the sky that should have been producing these neutrinos to begin with. No powerful events, including black holes and supernova, were detected from this area, so it was literally coming from the middle of empty space. And although it doesn't sound like it's a very important event for astrophysicists and especially for particle physicists, this was an extremely rare and very hard to explain anomaly that they still have no idea how to explain. Which is of course why it's part of the anomaly list as well. And now we come to a very large list of anomalies that have been happening for many years, but most of them, because of the lack of explanation, have basically become kind of abandoned because we just don't know what happened. One such event is a gamma-ray transient or gamma-ray explosion in a sense that happened for less than 1 second. And because it was so quick and nothing else was detected coming from this direction, even today we still have no idea what happened. It's as if something just suddenly exploded, disappeared, and that's it. So whether we'll be able to answer what happened here or whether it's going to remain a mystery, I guess only future will tell. But the thing is, this is not the only such explosion. We found a lot more similar events, some of them lasting only a few minutes, or this one right here lasted for several years. This was in a galaxy known as M86. And although technically we should be able to explain what happened here, currently the scientists have no idea why this unusual X-ray transient or this X-ray explosion was happening for so long and what could have caused it. Of all the anomalies related to gamma rays and X-rays, this one was the longest, so not having an explanation to what caused this is a little bit troublesome. But there were also similar anomalies in other types of light as well, even optical light. Back in 1989, scientists published this paper that described a very similar explosion, but in optical light, in visual light, that disappeared just as mysteriously as it appeared. And even today, after pretty much several decades, we still have no explanation for what happened here. It may have actually recurred several times and lasted for several minutes, but just like that, then stopped suddenly and never reappeared again. But there are a lot of other optical phenomena that are still not explained as well, including this right here. This was an unusual afterglow, not really an explosion, just a sudden appearance of light that just like that disappeared after a while. And most of these unusual phenomena are all kind of very different. They don't seem to be coming from the same event or same type of an object. This right here was a very strange flaring red object that flared for a little bit, produced a lot of red light, and then once again disappeared and has not been detected since. But of all of these unusual explosions, transients, and flashes that we can't explain, the two most famous ones must be this right here, AT 2018 Cow, that we're still kind of trying to explain, but this was one of the brightest flashes we've ever seen, and another smaller visual explosion known as Dougie, that lasted for a few weeks and then disappeared to never appear again. Both of these very bright flashes have been studied for a very long time, but even today we're still having trouble explaining what exactly caused them. So this is just to give you an idea that there are so many different flashes happening all over the place, but because some of them are so different and don't seem to share any features with common flashes, like for example with supernova, we are having trouble explaining what may have caused these events. And a couple of years ago I've talked about this event. This was another unusual explosion, but this time in infrared. And as of today, this event also has no explanation. It was a very unusual infrared explosion that disappeared just as suddenly as it appeared. And since this was the only unusual event happening in the system in the last couple of years, we haven't really been able to explain what happened in that particular moment and why it suddenly changed its luminosity by so much. But all of these transients, all of these flashes so far, in X-ray, gamma-ray, visual light, infrared light, all of them technically can be natural. Something could have exploded and produced all of this energy, and so in that sense, for SETI at least, it might not be as interesting. The more interesting observations come from radio light observations, and there are quite a lot of anomalies in radio waves as well. For example, if you were to look near the center of our own galaxy, essentially at the Milky Way itself, there's a very unusual area here that produces strange radio bursts that last for about 10 minutes and reoccur every 77 minutes, with a frequency of about 330 MHz. We don't really know what produces these radio frequency bursts, but the scientists right now nicknamed this burst Burper, because it looks like burps coming out of this region and we really have no idea what's causing them. And just like with other types of light, including X-ray, gamma-ray, and visual light, there are also these radio bursts that happen for no reason whatsoever. Some of them look like explosions, but only in radio waves. For example, we have some of them like this one right here that only lasted a few seconds. Some lasted a few minutes, some lasted a few hours, but the record here belongs to the object known as first J1419 18.9. This unusual radio burst lasted for nearly a decade. And the only possible explanation here is, well, this right here. This is not very likely, but it's the only one that makes sense. A jet from a black hole hitting something on the way and transforming into a radio wave. But even that has not really been confirmed or accepted by all of the scientists. So as of today, this is the strangest radio burst we've detected. And there are a lot and a lot more of these transients, these unusual explosions in various frequencies that have been detected over the past few decades, and many of them still have no explanation. And apart from just bursts themselves, there are also a few sources of radio waves, or essentially radio signals, that have been constant over time. They haven't changed much, and though some of them come from radio galaxies, we have no idea what's truly causing the actual radio signals themselves. And what's interesting about some of these radio sources is that they only seem to appear in radio waves. So here, three objects specifically, 3C125, 3C431, and PMN J1751, do not actually have any visible counterpart. In other words, if you were to look at visible light here, and if you were to look at radio waves, you would only see these objects in radio wave frequencies, and there would be absolutely nothing there in optical light or in any other frequencies. And this is one of the reasons these objects have been added as an anomaly, and we really can't explain what's happening there. Another strange radio phenomenon that still hasn't been explained is also once again in the center of our galaxy. It's this right here. It's known as the Galactic Radio Center Arc, and its current origins are a mystery. We don't know what caused it, and we have no idea what could have produced these unusual formations. But this region right here is where the supermassive black hole in our galaxy is, so some scientists believe that maybe this is actually the magnetic lines caused by the black hole interaction. If so, this would be a very interesting discovery, but they seem to only happen in one specific region of the galaxy, but this still hasn't been confirmed, and if it is magnetic lines, nothing else around the black hole seems to be affected by them, and also they only seem to be happening in that one specific region. So whatever is happening here is a mystery, and what created these unusual arcs is also an anomaly. But then we also have similar unusual sources of gamma ray radiation in our galaxy as well. One such unusual source of gamma rays is right here, and once again, once you look at this location in gamma rays, and then try to look at it in visible light, you'll find absolutely nothing in there. Whatever is causing these gamma ray emissions is invisible in every other frequency. It's only visible in gamma rays. And there are at least two different sources we know of that do seem to produce these emissions. But the most unusual of these so-called gamma ray emissions with no origin or no source are known as dark accelerators. This one here is one of the more famous ones, And for the most part, once again, we have no idea what's happening here, but these gamma ray emissions seem to be some of the most powerful gamma rays we've ever detected. But once you look at this location in different light again, you'll find absolutely nothing. They seem to have nothing there. And this creates a very big mystery. What can possibly create the most powerful radiation possible without any other counterpart in the region? There doesn't seem to be any black hole there, there's no X-rays coming from this region, there's also no known phenomenon to explain any of this, and so whatever creates these most powerful gamma rays in the universe is currently invisible and pretty much impossible to explain. And the Exotica catalog lists at least 2 of these dark accelerators, or these very mysterious gamma ray emitters of the most powerful radiation in the universe, but with absolutely no other radiation emitted to explain what's causing this. But this is just some of the mysteries and some of the anomalies mentioned in the catalog. There are so many more mysteries and so many more scientific discoveries that haven't really been explained, and we are probably not going to explain them for a very long time. This is why the Exotica catalog is one of the more important pieces of publication, not just from SETI, but just from any scientific community in the last few decades. It allows us to finally sort of establish the grounds for what we know, but most importantly, for what we really don't know. And by knowing what we don't know, we can then start looking for answers. Hello wonderful person, this is Anton, and today we're going to be talking about a new announcement coming from a very interesting experiment that suggests something unusual may have been detected, and that something may have also been the mysterious dark matter. So let's talk a little bit more about the experiment and what was found, and welcome to What the Math. So over the last few weeks there were quite a lot of different news coming about this experiment, but most of the headlines were basically suggesting that we did discover dark matter after all. And more specifically, the claim was that the scientists were able to see the mysterious axions, the mysterious particle that's supposed to explain the existence of dark matter and also solve a very unusual phenomenon in physics that still hasn't really been explained. But all of these topics are actually really complex, like super complex. So it took me a while to try to figure out the best way to explain all of this. And I figured the best way to start is, well, let's actually just talk about the experiment first. It's called Xenon 1T. And it's actually one of the more advanced versions of the original Xenon experiment that's essentially trying to discover all of these mysterious particles that are very difficult to detect, such as particles that could be responsible for the mysterious dark matter. The way it works is by using a relatively large tank filled with xenon, specifically large amounts of liquid xenon that usually doesn't interact with anything. And in this case, over the years, the actual tank has been increasing in size to the point where now we have a tank that's able to hold over 3 million tons of xenon on the inside. At the same time, this tank is placed somewhere really deep in the ground where it's protected from all sorts of interference. And it also contains a lot of very sensitive sensors on the top and usually on the bottom as well. And so what this allows the scientists to do is to basically be able to detect really minute interactions. Even like a single particle passing through this tank, in this case right here, would then be producing enough interaction with xenon that it would then be detected by these really sensitive sensors, which would then be able to create a three-dimensional picture of where this particle passed through. And because this detector is so sensitive and because it's able to pretty much detect absolutely everything, it's always very hard to actually protect this from unneeded interference. Like for example, from interaction with particles that we're not really looking for and that we already know a lot about. And so over the years, the scientists have created a kind of a baseline for what they expect to discover in these experiments based on the particles we already know about. So anything over this limit, over the expected values, will obviously create a lot of questions. And in this particular case, the scientists expected, theoretically, to discover about 232 interactions in the xenon detector over the period of its activity. The thing is, when they actually looked at the data and when they started to calculate how many different events were discovered, they realized that there were more, 53 more to be exact. And in this case, what they were actually seeing had the energy equivalent to several different concepts that were previously theoretical, including these so-called solar axions, which have previously been also used as a kind of explanation to the mysterious dark matter. So this is where things kind of get a little bit more complicated, because first of all, what exactly is an axion? So a few decades ago, when studying the concept of symmetry in the universe, or basically that everything for the most part seems to be symmetric everywhere, the particle physicists realized that when it comes to the actual subatomic particles and subatomic forces, the so-called strong force should technically be not symmetric. Now, it's a very difficult concept to explain in a single video, but the idea here is that mathematically and physically, it's more beneficial for different subatomic particles to not really have this symmetry going on. But the thing is, we don't really see it. When it comes to the strongest force, for example, the so-called strong force that holds protons and neutrons together, it really should not be symmetrical at all. And if it's not symmetrical, we should be observing a lot of other effects in the universe that we're not seeing, such as, for example, the neutrons should have magnetic charge, which they don't. But that's a really simple explanation here, and if you want more detail, you can check out the PBS video that should be linked somewhere in the description. The explanation there is a little bit more thorough, but also a little bit more complex. Now, axions, the mysterious particles that we've never been able to detect, would totally explain all of this away. The existence of mysterious axions would explain how subatomic particles and subatomic forces are able to maintain this symmetry, and would actually explain how everything kind of works together. The problem here is that we've never been able to see these axions, we've never been able to detect them. And that's actually by their design. A typical axion would have no electric charge, it would have an extremely small mass, it would barely interact with anything at all. But according to the theories of axions, they would all be produced, for the most part, during the early existence of the universe, during the Big Bang. And there would be so many of them produced that they could easily explain the effects of dark matter we're seeing around the universe. So even though they don't interact with anything, their actual sheer numbers would be more than enough to explain the actual dark matter we're seeing around the universe. While at the same time, they also take care of the so-called CP symmetry, or the symmetry of the strong force, which has not really been explained just yet. So in other words, these axions would take care of two problems, and because of that, back in the days, one of the scientists decided to propose the name axion, which was also a name for a detergent, which basically cleans your clothes. So in that sense, because it clears up so many problems, one of the scientists thought that this is a perfect name for this subatomic particle. But because we've never actually seen them, we've only had a few proposals for different experiments to try to detect these axions. One of the more interesting experiments that tried to discover axions was actually by using their very interesting property where an axion can turn into a photon and then back to axion if a magnetic field is applied to it. The wonderful person by the name of Axel Lindner created this illustration that shows you how this works. Essentially, if you were to shine a light onto a typical wall with electromagnetic force applied right here in front of the light, we expect some of these light particles to turn into axions and to essentially pass through the wall. And then if on the other side you do the same thing and now use the electromagnetic field to try to turn the axions into light, you should technically be able to detect some of the light coming through the wall. In other words, by design, axions should allow light to pass through walls, and we should be able to see things coming through walls all the time. But the thing is, we don't see that, and a lot of these experiments so far have failed. And mostly because we think that it's just very difficult for axions to interact with matter, even when we try to force them to interact with that matter. And so the experiments so far have not really been that successful. But one of the experiments expected to find axions using the xenon detector I previously mentioned. And specifically because we also expect the biggest light producer near us, our Sun, to produce lots and lots of these axions, and a lot of them should be passing through Earth right now as I'm speaking. Essentially, we expect axions that are created inside the Sun, because it has a lot of magnetic field and it has a lot of photons, to eventually be detected here on Earth if we wait long enough and if we use a sensitive enough detector. And because Xenon 1T detector did have these unusual 52 events that cannot be explained in any other way right now, that's why some scientists claim that maybe this is what we're seeing. Maybe we actually finally found axions coming from the Sun. But right now we do need to have further investigations because there are two more alternative propositions. One of the possible explanations is that there is a slight chance the tank may have been contaminated with an isotope of hydrogen known as tritium. Even a single atom of tritium would actually produce very similar effects that we observed in this particular experiment. The other explanation involves the mysterious neutrinos and the idea that maybe we just don't understand neutrinos very well. Neutrinos can also pass through the xenon detector because they normally don't interact with matter as well as other particles, and so if they actually have slightly different properties from what we initially thought, maybe that's their fault, maybe they were responsible for these unusual detections. But nevertheless, the best explanation right now, the most likely explanation at least, are the axions. They have the highest chance of being responsible for what the scientists observed in the xenon tank, and the only possible source for these axions would be our sun. So technically we refer to these as the solar axions. But does this mean that we finally found the mysterious dark matter and we finally know what it is? Well, not just yet. The xenon experiment still has at least one more upgrade to go through, and this will allow us to kind of really narrow down what we've found here and what's basically causing these unusual observations. Once we can identify exactly what caused these observations, we'll be able to tell for sure if what we just saw was dark matter. But as of right now, as of 2020, this has been the best chance for us to discover the mysterious dark matter, and if axions have indeed been discovered just now, this would clear up a huge amount of problems for the particle physics and would allow us to understand the universe in a lot more detail as well. Right now, we sort of depend on the axion existence for essentially understanding the universe, and without their existence, things get a little bit more complicated. But anyway, whether this was the signs of dark matter or something completely different, there are still going to be more investigations about these particular detections, and they will definitely lead to something exciting in the future. And once we learn what it is, I am definitely coming back and talking more about this in some of the future videos. So make sure to subscribe, share this with someone who loves learning about space and sciences, and maybe come back tomorrow to learn something else. Alternatively, you can also support this channel on Patreon, and it does help me quite a lot. And maybe support this channel by buying the Wonderful Person t-shirt that you can also find in the description below. I'll see you tomorrow, space out, and as always, bye bye.